So, good morning, everybody. Welcome to this fourth edition of the Zak World of Façades event here in Hong Kong. My name is Ahmed. I'm part of the organizing team here at Zak. I'll quickly introduce the event. I'll introduce our event partners and then we'll get into the action shortly. So, we've been organizing the Zak World of Façade conference series since 2012. This is edition number 194. We've finished around, we've organized this event in 47 countries. If you see, the events are spread all across the globe from New Zealand up until Canada. We've gone to some exotic locations this year. We went to Georgia, Tbilisi. We went to Uzbekistan, Tashkent. So we keep exploring new regions, and most of these places do not have an event on facade engineering. There are more interior design, architecture events. What we do is we try to get inspirations from one region and then bring that to another region. And we have people who are facade enthusiasts educating the audiences in different regions around the world. As you all are aware, facade engineering is a new profession, at least compared to the other existing building professions. So it's good that these kind of events, courtesy our event partners, happen in all these kind of places and just not the major cities of the world. That's our original aim. Of course, we are coming at a time where Hong Kong is not at its 100% peak, but I think like any other global city, Hong Kong is also a very resilient city. We've seen major cities like New York, like London, bouncing back after major issues. I'm sure Hong Kong will also bring its glory days back soon. Okay. Yes, so this was our 2025 calendar of events. A wide range of events, and again, the way facades are designed, engineered, installed in different regions are completely separate. The Middle East is going berserk with all mega projects. I think the Western countries, Europe, Americas, are more about adaptive reuse, renovation, carbon control. So the way the contents are presented across our events are a reflection of what's required and happening at those respective locations. Again, our event partners, who we are extremely grateful for always in sponsoring these events globally. I'd like to take a moment to mention all of them. I'll start with our associate partner, AGC. So AGC, again, needs no introduction, but they're one of the leaders in high performance glass products, coated glass, photovoltaic, vacuum insulated glass, LED glass, a lot of other product ranges. It's part of a bigger group of other building material products. Anometal is from the Shandong district in China. So they've got pre-anodized aluminum panels, which are used as a cladding application. Elval Color is from Greece. So they are a global leader in non-combustible aluminum composite panel and coil coating solutions. Far East Façade, again, needs no introduction, one of the global players in the curtain walling industry with a wide range of complex projects in their kitty, and a couple of other photovoltaic products and other high-performance facade products. Huajian Aluminum, I hope I pronounced it right. Again, a leading extruder out of mainland China with big capacities for and extruding jumbo size profiles. Curare is the mother company of the laminated glass interlace, Throsifol, and Sentry Glass. So Curare are one of our global partners across all our events. Last bit is from Czech Republic. They've got cast glass and other value-added glass products which can be used on the external facade and internal glass applications. Rotoblas is from Italy. Rotoblas are world leaders in solutions for the mass timber industry, but you can use the same products on the building envelope. They've got pacifier protection, they've got fall protection, and a lot of other products. Like Rotoblas, all other sponsors have their booths outside, so please do meet with them in the networking breaks whenever you can. Sedak is one of the leaders in high performance value-added glass, jumbo glass, curved glass, and other types of glass. Of course, you'll be hearing from them and others on what they do, and of course, their references here in Hong Kong. Sedak is part of the Sealy Group. Tremco is an American manufacturer of sealing and bonding solutions. They've got fire stopping solutions under the Nullifier brand. They've got sealants under the Tremco Ilbrook brand, weatherproofing products, so a wide range of products. Ever grateful to the support from the Hong Kong Façade Association. It's the fourth time we are collaborating with them on this event, and you'll hear from them on the current state of the market and what they plan to do during this time in the development of the same. In the wider region, our next event is in Shanghai next week, which will be our third event in Shanghai. Seoul, which is on the 11th of September. That would be our third event in Seoul. And slightly wider region, I think in Australia, we're doing our first Zak Awards for Excellence in Facade and Fenestration. We've had a couple of them in the Middle East, in India, in the UK, when debuting with our Australian edition on the 18th of September. So that's a gala awards dinner, and there are plenty of projects in Australia which have a lot of innovations in facade design and engineering, and that's something different we do from the conferences, but again related to the same industry. We've recorded today's event, so those speakers who have given us permission to share the recording with you, you'll see their presentations on our YouTube link, which will reach you a week from now. Then you can go and see the presentation in case you missed anything. So that's it from me. I'd like to call upon today's event host and convener, Jovi Wong. He's managing Inhabit business for Hong Kong and Macau. He's going to be taking you through until the end of the day. And I hope you enjoy today's program. It's all about storytelling from different speakers. We've got some excellent topics. I've had a sneak peek at most of the presentations. So they're excellent, a lot of content, a lot of knowledge, a lot of complex facade engineering being discussed, which is very unusual because in Europe, they all talk mainly about adaptive reuse, renovation projects. So it's nice to see presentations on high-performance complex facade engineering being presented for a change, at least for me. But I hope you enjoy today's event, and I look forward to meeting all of you at the end of the day. Thank you.
Good morning, everyone. Welcome to Zak World of Façade Conference in Hong Kong. It's a wonderful time to see both a familiar and new face today. I'm Jovi Wong, Director of Inhabit Hong Kong and Macau, part of Aegis Group, and your MC for today. I'm pleased for guiding our discussion. The time of the year presents a great opportunity for us to come together and explore the latest trend in facade design, sustainability, and technical solution. We are at a pivotal moment in our industry. The facade has evolved from simple being a building envelope in a dynamic interface, one that responds to challenges like climate changes, urbanization, and sustainability. And expectation grow. We are being asked to deliver innovative solutions that improve energy performance and support well-being. It's essential that we continue refining our strategy, especially in addressing climate changes and long-term maintenance. Inhabit is proud to contribute to today's dialogue, particularly on the topic of reflected solar glare, an important issue when balancing aesthetic with functionality. We are being joined the panel for climate resilience, where we discuss how facade can help reduce climate risks and extend the life of the buildings. We have a strong lineup of speakers today, including architects, developers, consultants, suppliers, and other key industry stakeholders, each sharing valuable insight from their projects. I encourage you to take actively in today's sections. Your input is key to shaping the sustainability and resilient future. To begin, we would like to invite Simon from Hong Kong Facade Association to deliver our opening address.
Good morning, ladies and gentlemen. Welcome to the Zak World of Façades conference today. I'm really excited to be here as the president of Hong Kong Façade Association. It is real honor to share our vision with you since 2006. And Hong Kong Façade Association have been connecting, aligning, and promoting the sustainability with the organization and the individual as Hong Kong. Our mission to embed sustainability practice into the building design, create greener city that reduce the environment impact and improve our quality of life. And facades are where the aesthetic, technical performance, and urban identity come together. The aesthetic side make our building shine like the dancing light along the Victoria Harbour that giving Hong Kong its iconic looks. Our technical side, facades are engineering for durability and efficiency, ensure the building stand alone, strong for and performance well. The key performance of facade, it needs safe energy, handling our climate, and keep occupants comfort. Urban identity that create the facade more beautiful for us. And from the climate change, it is a mass challenging with the heat wave, flooding, and storm hitting our environment. That's why we focus on the carbon offset initiation to move toward the fast carbon neutralization. The building sector accounting for about 37% of the global energy related to the emission. So it is a huge opportunity for us to change by using sustainability material, energy efficiency, and facade design, renewable energy like the solar panel. This step fight to the climate change with our buildings. And recently, we're facing some challenges and the pre-COVID situation. Hong Kong government rely on the land sale for the revenue and funding to the low tax system and public sector. And during the COVID, construction sector turned down, facade faced to significant challenge. And at 2023, almost 20,000 unsold flat and at the port of the Kai Tak sold at the lowest price for 9 years. Okay, 2024 first quarter, the government suspend the residential and commercial land sales due to weak demand and high vacancy rate. And this year, home price dropped 8% year on year. Grade A office value down 40% since 2018. So ongoing, we have a high interest rate, slowing economy, and geopolitical uncertainty, lower the development confidence for buildings. So Hong Kong Façade Association commitment to the futures, we commit to maintain the standard high quality sustainability building envelope, advanced facade technology, and also the building the green Hong Kong city. And finally, we hope we can the Hong Kong facade industry can explore more market overseas, so that we can sell our engineering and technology to other countries by using the set facade conference platform to selling our product. And we are very happy to stay here, and thank you.
Thank you, Simon. So I don't want to waste everyone's time. I would like to invite our first speaker, Michael from Fire Global Founding Partner, to talk about scale matters.
I just got off an airplane a couple hours ago, so I'm a little bit lagged, shall we say. don't. If you have a choice, don't be the first one to be speaking after a 15-hour flight. So today I wanted to not necessarily look at the most typical types of projects that are talked about in these events, and look at titled it Scale Matters, which means that as a practice, we have always been interested in looking at different projects of different sizes and scales, and they give us different values to us in terms of how to be able to engage in the project and the level of engagement, depending on the project scales and sizes. So that's what we'll talk about today. The small one is represented by a bench in Hong Kong, and a medium one is a museum that we had done a number of years ago in the US. And then the last one is some high-rise buildings in Doha, Qatar. I want to talk about these projects in the context of two topics. One is the use of bare aluminum, and then the other one is called Elephant, which is a process that we've been developing for about 22 years in terms of the process of how we do things. Aluminum, as we all know, are probably the most familiar, aluminum and glass. That's our industry. Lately, we've been hearing a lot of difficulties with the aluminum because of its carbon footprint, inherent carbon footprint. And of course, there's also environmental issues with these things. But because it is such an indispensable material for us, we need to look for a way to still utilize it and utilize it in a way that is the overly used were sustainable. Back in 2005 or 4, was it? We started a project in this is Prada Beverly Hills store. The facade panel there is made out of aluminum. It's 15 meters wide by 4 meters tall as a single sheet. And it was manufactured by folks that are typically manufacturing airplane wings and such. And because we didn't have this kind of agenda about being environmental, but there was a question, how do you finish a panel that large? And originally this was made by Alcoa as a hot rolled plate, a single plate. And the solution was to not finish it at all. And of course, the problem with not finishing aluminum is that it corrodes often. However, because this one was utilized using a 1000 series alloy, which is almost pure aluminum, the corrosion resistance was very, very good. And it stands there today looking pristine as day one. This project, of course, it's already been a number of years since Sishu Opera House has been built. Bing Tom, who we worked very closely with, had this idea of having a very, very rough exterior. He mentioned it like, I want it to be like an oyster, and then the inside is very smooth. So we proposed this idea that maybe we could use this raw aluminum again. And the other advantage, of course, is that you don't put the anodizing or other kinds of finishes. It is one step peeling away the environmental impact. So in that way, there's a kind of positive side. But at the same time, it does allow the building to sort of age and patina over time, giving it kind of a character which cannot get with a painted finish. The second topic, I'd like to discuss those 3 projects that I mentioned, is that this is your typical sort of concept through fabrication, construction, rough steps. And as a younger man, 25 years ago, when I came into this industry, just one thing that I noticed is that all of our kind of heartaches and difficulties of construction comes from this division between design and contracting or building. And we thought, at least from a facade standpoint, is there something that we can do to bring these heads together into the process? Not always, but sometimes I would say, and I have heard many people refer to it as the process is kind of broken. Could we bring all of that into an umbrella? Well, that is not suitable for every project, but some projects, maybe it is suitable. So as we were pondering about this problem 22 years ago now, there was a kind of a made-up project. Initially started out as real, but often architecture projects don't get built. This is one of those. The client is a glass supplier manufacturer in Brisbane, Australia, and the gray box is the factory, and they wanted us to design a enclosure for the office and showroom. So we wanted to implement these ideas, how to create an idea and then how to see it through the project, use the design information and the conceptual information into construction. So the building is actually quite simple. It's a series of ribs. So in some ways, it's kind of a laboratory test to see if our ideas could work. Back then, the best solution for platform was CATIA. Later on, we changed to other platforms because of the complexities of CATIA, but at the time, it was the best one. And the idea was to be able to do the design work, pull out the representation to show to your client, work out the details, and use the same model for all of your engineering as well. Once that's done, bring the model back together, do some more studies, and then ultimately get to this kind of dumb drawing on the left from this model on the right, which is to be able to automate those kinds of fabrication information, whether it's through a PDF or hard copy or a digital set of information. And the power of it, of course, is that, I mean, this is sort of outdated discussion because this was 22 years ago, that if the hole placement where the bolts are going through the glass is misaligned or too close to the edge and we needed to pull it back in, and it comes quite late in the game, in order to change thousands of fabrication drawings, this is all done in the model. So it's kind of an instant result that comes out from that. And then later on, we developed it further and called it Elephant. And through utilizing that process, these are the projects that were achieved. Most of them are built, except for one, which is this one in Gabon, Africa. So with those two things in mind, the use of aluminum and then kind of thinking about how to improve the process a little bit, we'll go through those three little projects, where one small project, medium project, and a large project. So the little project, which is a bench, it's in Kaitak airside building done by Snohetta. And the bench itself was designed along with Miriam and Tom. The design of the bench sits inside of the main lobby. If you go there, you can have a look of the office entrance, lift lobby. And the original shapes, we went through a lot of different materials and landed on and inspired by what Kaitak used to be, which is an airport and airplanes. And it was a kind of a perfect fit in terms of the materials and the methods of construction. So a wing component of an airplane is basically made out of a waffle grid of framing. and then it's skinned over with the aluminum skin. Of course, these days there's composites being utilized, but aluminum is still a very important material in aviation. And so you can see here the very simple waffle grid. The advantage of the waffle grid, of course, is that you can pretty much get any shape that you want with two-dimensional plates. And then you can skin the whole thing over with a 4mm thick aluminum sheet. Before we made the full one, we made a mock-up 1/3 of it to see and test out different surfaces and treatments and the quality of the laser welds that goes around the edges. And before that, we went through a lot of sampling. And through the sampling, this is kind of like you take a normal sheet of aluminum, and this is 5754, which is the marine grade alloy. Again, trying to do this without any sort of coatings on it. You notice that there are these kind of little highlights that is not so great to look at. It gives you that kind of tinny feeling, a little bit cheapness to the material. And we look for ways to kind of bring the real beauty out of the potential beauty out of the material. And so looking at different kinds of stages of finishes, starting out with a vibration finish, and then also getting into little things like making sure that all the bits that are being utilized for making these grooves are relatively kept clean and new so that you don't end up with these jagged edges. Bit of sandblasting and buffing in the end started to get us to where we wanted to go. And here you can see the pattern being milled. And then just utilizing very standard rolling technique in order to give the curvatures. And then the bench itself was slightly modified as we went working with the manufacturer to suit their abilities to both meet the cost and their abilities. And this kind of working relationship really is enjoyable in the end, rather than kind of butting heads and fighting with each other. And you can see the quality of the surface there, which is a very, very natural surface. And if you go there, you can touch it. It has a very leathery, satiny feeling, which is very unlike of much of the aluminum surfaces that you might touch. Here at the seams, we have laser welding going on. And then the result of the laser welding. And then that's the actual seam there, which has been ground away. And that would be kind of at the corner edge where all of the welding had been done. And when you get the lighting, you start to really see the bench and its material start to come alive. And there it is at the final resting location. The second project is a museum, UC Davis, California, with architect Soil, who were very dear friends of mine, and their partner architect, BCJ. Again, utilizing material, the same material, uncoated, unfinished, but also the process where we get involved in the concept design with the architects, and then our information flows all the way through manufacturing with the manufacturers directly. So as you can see, the project is original. This is the kind of the original conception, which is that you have main structure for the canopy, and then sort of this screen that's been applied to the underside of the canopy to create the canopy. And a view from the underside. And then the context, here's the project there, and then vast amounts of farmland around. And we thought that the framing could be the shading. So instead of having framing and skin, this is more like just framing. Really inspired by the aesthetics of this farmland, which are these kind of three-dimensionalized, triangular-shaped aluminum louvers. So the louvers are then subdivided into these kind of farm-like plots. And of course, the drawings are done. And so what's the shape? What's the shape going to be? Okay, well, you can take a typical sort of rectangular shape, and you want to get a little bit more shading, so you broaden out the top. And then at the bottom, you don't need as much, so you squeeze that down a little bit. Engineer it, and found out that by adding that little bit of extra bit at the top, that gave us the exact amount of stiffness that we needed. And we draw it up, and we make some mock-ups with the architects. Look at the samples and finishes. This is the first sample that we got back when our office was in Taiwan. And you can see the mixture of kind of different parts and pieces that fit to form that canopy. Here you can see the engineering to the left and the actual testing on the right, which gives us very similar results. The other thing is that installation, when we're responsible for the design, we need to make sure that it goes relatively smoothly during on-site as well. So lightweightness is kind of a feature of this. And the contractor who actually did the installation was able to install this 2.5 months ahead of schedule because of the ease of installation. You can see the coordinated locations of where they're supported along the main steel. And then the underside of this, UC Davis, California, if you guys haven't been, it's a very, very bright sky with very blue color. And the aluminum with its right kind of mechanical surface finish worked very nicely with that sky. As you can see, the shadowing effects are quite strong, heavy contrast. And then this is at the opening day. Last project, sorry to ask, how much time do I have? There it is right there. Okay, 6 minutes. I'll have to go through this a little bit faster then. Okay, so the last project I wanted to share with you is the Lusail Towers in Doha, Qatar with Foster and Partners. Another project where we began with the architects from concept. And these are renderings, of course, just some early renderings to show you the design intent and at the lobby level. And that construction schedule was all contingent upon the activity that was going to be happening here, which is the World Cup. And so early design phases, we needed to kind of understand the geometry. It looks like it's twisting, but it's not twisting. It's just simply squashed at the bottom and then churned 90 degrees and squashed at the top. So you can see how the geometry is derived. And then what makes it look kind of twisted is because the skin then wraps around that that geometry. Of course, when you're wrapping around that curved geometry, there's different ways to solve how the panelization works. You can, of course, triangulate it. You can do planar quads, which are kind of these flat panels that are popping. And then you can do cold bend. After a lot of studies, we found that actually the cold bend meets the design intent, and production time was faster. Thermal performance was better, and material efficiency and cost, well, it's a clear winner. But the challenge was, how do you maximize the cold bending? The other option, which was very seriously considered, which is what we call the popping scheme, negotiating curved geometry with flat panels. We did another project with Foster's a long time ago, looking at that. And this was a bit different in that this is a double skin facade. But for this one, it proved to be a really, really great solution because the exterior didn't have to meet the performance requirements as much. You have an interior skin that does all of the work. And so the exterior could have this kind of flat expression. It was certainly low cost. And it also added this kind of visual characteristics of these little slivers that you see as you look up on the building. Back to the Lusail Towers. If you look at these plans, you can kind of see the arrangements of what the building is. If you cut sections in plan, you have these aluminum panels that are directly onto the facade, really creating a low amount of, or high amount of insulated area and shaded area. You can see the glazing to opaque area ratio. Some areas are longer spanning, so you have steel inside, and then other areas at the bottom, we just have those kind of right in front of the glazing. And here you can really see, this is a real image, not a rendering. You can really see the level of opacity for this building. And what's also remarkable, I think, architecturally, is that there's no typical clues of a high-rise that you normally see, right? We normally see some mechanical louvers, or you see some sort of a crown articulation. But the intent here was to create these kind of very platonic objects. Some matrix to go through, 244 stories across 4 towers and 1.1 kilometers in total height, so on and so forth. So the numbers are quite high. The schedule was very intense. Started at fall 2018, and then we switched hats as we moved along. The project ultimately ending up, and that says front over there because I was front. And then completion by 2022. It's very, very intensive schedule. And then on top of that, of course, we had this. So initial design stages, I'm going to have to go through this rather quickly because of time. I only have a minute left. So there's just a lot of analysis that goes on from the beginning throughout the process with the architects, checking geometry, checking efficiencies, making sure that we're doing the right thing for, in the end, can this thing get made on time? Maximizing sizes, and also coming out and drawing out all of the building material, doing all of the kind of what we call math engineering, checking thermal performances. We were able to, majority of the project is utilizing cold bent glass, maximizing cold bending by studying all the way down to the interlayer stress, the spacer stress, the secondary seal, and the butyl stress to make sure that those were compliant when you're pushing the glass into shape into the panels. And here you can see some of the construction. You can see the level of kind of warping going on there. And this is the kind of the mass engineering that you're able to do from when you own the model, you can pull through all of the engineering through there. And these are examples of the factory shots. We're very intimately involved in the factory and how they actually went through the process of production, utilizing our information. And that was really the only way to meet the schedule. This is from a different project, but the process is exactly the same. Producing drawings for manufacturing. And I just wanted to close with a couple of videos. Hopefully we'll have time for that. So the difficulty about these unitized panels is that they kind of hang over. The cladding parts are triangulated and hang over below the spandrel. But in the end, it's unitized curtain wall. Sorry about this dramatic music. The roof isn't done there, but the roof is also finished with the same return over the top so that the purity of that remains. And those BMU machines actually go down, recessed under with a finish hat on top of it so that it gets hidden when they're not in use. And then we'll skip down to the bench. Obviously, this is a low-quality iPhone video. No. And lastly, this is the video done by a company called Another, or the DUC Davis project. Okay, thank you.
Thank you, Michael, for giving us interesting projects from large scale projects like with complex geometry and small scale projects with high level details. And please stay for the whole section because we will have a photo shooting after the entire section, even you have a long flight. So we would like to invite the next presenter, Vivian, a design principal from NBBJ, talking about the X marks the spot crafting a landmark for Nishi headquarters. Thank you.
Hi, everyone. It's great to join you from Los Angeles. It's always great to be in Hong Kong, where I was born and raised. Today, I want to tell you a story about Lexing. This project is in Shenzhen. It's really right across the border from Hong Kong. You can almost see it when you've crossed the bridge. So I think this is part of the story of this Façade conference. And it is a story about construction and realizing a design vision. Today, I actually asked my client to join me, the manager of the construction site, David, but unfortunately he has some family issue that he couldn't join me. It's really his ADHD tendency that made this project this so amazing so far. It's being constructed, and it will be open later this fall. And I want to share with you right now before it's completed, before it was all buttoned up, because it's really a story about construction and design. So Lexing, I think it's quite a well-used app. It's a digital finance. It's really about crossing finance and technology and new way of moving money around, almost exchange money, exchange lifestyle, and really open up business to the new generation. So this idea of exchange is very important to us. Exchange of enjoy life and technology and happy life balance. So I think when we were competing for this project, when NBBJ competing for this project, it was during middle of COVID. We were chosen because of this amazing vision. Also, maybe because the X is also the CEO's last name, Xiao. So, but it could be just a coincidence. But it's also an exchange. It's also located as an exchange in the urban tenth. It's in the corridor of Nanshan and Futian. So it's really about almost the new technology and and the old finance of Shenzhen. You can see at the crossroad of Hohai, right at the crossroad of nature with the People's Park, and also all the tech firm and all the most prominent companies in Shenzhen. And the site is actually really cut by this green line. And you can see that it's only really cut into a really small site, and it will, start a story of a really hard to construct, really small staging area, which makes, the construction quite small. But, it's hard to say small in Hong Kong because it's probably really big in Hong Kong already. But it's only a 1,500 square meter. Most of our headquarters that NBJ does in China, it's up to 3,000 or 200, 2,500 square meters. So this is a really tiny. But it's because of this small scale that we were able to achieve really meticulous and really accurate construction, the methods. You can see this is a stage, 3 cranes fitting into really tiny site. We had to borrow land from the government to set up all our, the staging and for all that material. So it makes it an additional challenge to what we want to do here. But what it lacks in the size, it brings into this amazing view. This is one of the sites in Hohai that offers this amazing open view to the entire bay, the Hohai Bay, and also the park in the front. So this is one of the kind of the best plots we believe that offers this amenity. So and it's also right next to the really prominent buildings and landmarks. So we want to make sure this building is a very tiny building in a tiny site, but it marks the spot. It makes this presence amongst all the players in this area. So the 3 really major design intent that we want to make is make sure that we have open views, take advantage of this natural site, and also expression of the brand. Because when Lexing built their first first headquarters. This is their kind of first stake, into this whole high area. We want to make sure that it's known, it's present, this brand is known. And also, lastly, we want to take advantage connecting to the green network that is set up, and then to the bigger, the seafront, the oceanfront park. So when we say X marks the spot and this exchange, it's really being done by this, pouring. You can say that we create these like tube-like almost corridors among the entire, square site. It's actually not a square, it's a little bit askew, but you can say that, it's this tubular shape, able to cross in different ways and able to form these networks and crossroads. And then these crossroads are celebrated with a really special area that I'll go into. And then another, most importantly, is that we cut this, at the base, we cut a big chunk out to open up and create this courtyard. And that takes advantage of the green connection at the base. So it's really from top to bottom that we want to express this almost pure geometry. And then, something so pure is actually really hard to achieve because there's forces against you in many ways for you not to do that. And then because of this, almost like a double helix, right? There are a collaboration meeting spot, and also I'll show you later a connecting stairs that connect throughout the entire building. The CEO really wants their first headquarters to be really promote this connection and almost seamless, no boundary type of work environment for the next generation of technology workers. So at this exchange, we have this urban view looking at Hohai and then looking at the Nanshan area. So these major almost natural landmarks of Shenzhen. And then we have a lot of amenities, climbing walls, and then almost a forum for their major events, and then reporting of annual reporting. So this is a very dramatic view. But it's almost, this is how it is that we want to see it. This is the branding of Welishing and the Hohai area. So the expression of brand, open view for all. So I'll go into how the facade, works, the type of glass that able to have such a contrast of transparency and high efficiency and low E glass to be able to achieve this look. And also I'll have a friend to join me later on to talk about this, almost floating glass. And then at this, triangle shape that it's cut off, almost like a table having a leg cut off, but still able to stand. It's kind of like magic. Okay, so I'm going to go into the tower. So you can see that the tower is really simple. It's very similar to Michael's. It's like at this a diagonal shape going up. But then you can see that the geometry, it's the X actually is formed by this giant cut. It's actually not just a cut on the surface. It's bended in two. It's folded in two ways. So you can see that none of the surfaces are aligned. The X itself is not aligned with the facade tower, and this actually creates a lot of very complex geometry. So this is you can geek out on this geometry, but we spent a lot of time finding the best, the perfect angle to achieve all those three ideas that we want to achieve. The X, right? The cutting of the bottom, that makes sense. And then this expression of the diagonal throughout the tower. So we have to find out exactly where we should want to set up this geometry. And so that all of the sides meet at the right location and able to achieve like this very, very clean look. And this actually took us a long time. And then we had to set up a coordinate system in order in the future you can build it very accurately. So there's the inner facade that folds, and then there's an outer facade that folds. And both of these need to meet at the exact same angle and the corner. So, we always say, China construction, right? It's like, well, it's kind of, sometimes it's like, 差不多, right? Just right, it's okay. But in this building, there's no 差不多. If you don't meet this, you will see it. So that's why, this the client's role is really important. David, our on-site manager for the construction, his tolerance is 5 millimeter. He told his contractor he's gonna put a laser through, and if nothing aligns, he had to do it again. So because of his kind of meticulous nature and kind of this high demand and high expectation, Zhang He, which is our facade contractor, able to really rationalize, and they went through a lot of thinking and to build this. But before they build this right now, the team has to think of rationalize this folding X, and you can see that in this section that there are two giant beams that are supporting this very clean in order to have almost like a column free in between this X shape. And then we have to have a inner wrap, which is a matted copper, and the red outer wrap, which is a reflective chrome-like shape. So then we have these two contrasting. So but this, as this goes up, all the section changes. So you're talking about throughout the entire building. Let me try this cool feature. Oh, there you go. Throughout this entire building, all of these are changing constantly. And nothing is really, you can see that there's a lot of condition here. And then, during COVID, you have nothing really to do. So, we really take out our geometry book and really figure out all the triangulation and all the, to really look at all the condition and really calculate almost trend drawing and calculate how much these in, and almost, had to customize each of these connections in order to have it perfectly match at the end. So at the end, in our documents, we're able to find out all the connections and able to, have all this drawing to able to guide the future Zhang He to build this correctly. So yeah, and then we have we had to devise a coordination system in order for them to accurately, because they have to meet at the corner. So this is our BMU, the first BMU. I mean, they did really good job. We were really happy. We were really worried. So, and then we had to see this in person. It was, it was a challenging because nobody can enter China, but we were able to, do something and able to see this in person, and really, we feel really comforted that they could achieve this. Yeah. So this is the kind of the chrome exterior. And then all the fin, I'll go into the fin that it needs to be in the exact angle, meet at the exact corner. And these are some of the material that we were sending to China to make sure that they're adhering to our vision. So this is 2 months ago when we went to walk the site. They're pretty much getting all the major structures in there. I think they're about to put in the facade starting, I think, later this summer. So we'll definitely looking forward to that. But so far, everything is meeting at the very, very accurately at the very location that we would like to. And also adding to, the X, the X concept, we do have these stairs that are floating and following the entire X. So then, everything's connected along the side. And then they eventually arrive at the exchange and location point. So yeah, don't screw your cell phone while you're walking on this. It's quite steep. So it goes all the way to the lobby. So it's a really true, connection through the building. So I'm gonna go into the main facade. So the main facade is really, again, this pure geometry, this this slanted, and again, meeting the corner is so important. So these are aluminum fins that are at an angle that is be able to provide the maximum shade and the maximum performance for the office building throughout the entire floor size. So we kind of have to find out the most optimum size and optimum depth in order to achieve this very clean expression. And of course, there's, in China, there's operable window. In order to achieve that, we were able to have, inset window and really set all those kind of fuzzy and all the distraction back from this facade. So this is how it is at the construction site right now. This is the laser test, right? So all of these pass the client's laser test, and the red that I highlighted is where they will embed the lighting. So all of this is one system. There's nothing extra sticking out. It's all part of the fin expression. So this is from Zhang. It's kind of the rationalization to make sure. So we also wrap around the roof as well. So everything is really pure and accurate. So some of the construction photo, it's actually really, really hard to have a straight line. I mean, when it is a straight line, it's very easy to stay out of it, and people will notice because. So this is actually quite amazing. This is actually what kept the team up at night most of the day before it was construction. So now that all of us can really rest knowing that this is being done in a very, very accurately. Yeah, and the corner is actually really, the team spent so much time finding out the perfect angle to achieve this seamless look. So, so this is all the geometry. So I'm going to go into the base, which is the triangle. So this, again, it follows this geometry. So when I zoom in, you see this tower. You think that it goes all the way down straight, but no, we just cut a giant a chisel out a corner because we want to open up this to the green network. And this is a huge challenge because you can see that the structure line don't work, right? They come down, and where does it go? But then, what we can do is that what it does is that because of the chisel out, we're able to create this almost courtyard-like with the, we cut out a part of the triangle, and it became the cafe and the retail, and then it becomes a courtyard. So I think we all think it's worth it, but the engineers might be scratching their head. And also because of this cut, the core, it's in this shape. So, but, the client sees our vision. He believes that we're doing the right thing, and he's able to, align with us to really push this idea forward. So it's really high transparent glass that's almost floating in this cut geometry. So you can see that this line of, so we have to find the structure line of force, and you can see there's a lot of different experts. I think the client went through 4 or 5 different structure experts to find the one that will support this, and then just to convince the government this is great. So and then it's a huge engineering just for the main structure to be able to achieve. Yeah, you can see there's a lot of bracing that's happening behind the scene. Very complex welding and complex sections. This is the size of it being installed. Yeah, all of this is being able to install it in a very small site. So once we have the main structure, I want to invite my friend Yan Shi. Oh, right here. Our friend from EOC were able to help us achieve this very, very transparent look. Come over here if I can.
You hear me? Great. Fantastic. Can I stay follow the clicker?
Oh yeah? Okay. Yeah, you can do that. Okay, sorry, one more side. No. But this is you can see that the weld is actually really clean. I just want to highlight how clean this is. This is almost a 6 cm weld, and you see how this is almost disappear. I just want to show you, it can be achieved in China, the construction. There you go. Now it's...
Thank you, Vivian. So this is a bit of a cameo, a bit of an engineering interlude. We're structural and facade engineers, and often we get brought in to deal with specialist features, and this was the case. So Vivian's team contacted us during this project on this feature. The original design intent was for a more conventional steel transom and glass fin approach. but there was an aspiration to turn this into something that was visually more transparent. So the question was, how do you do this as a cable net structure? So off we went, compare the two. There's definitely pros and cons to either option. Cable option obviously increases the visual transparency, but what it does is it introduces more complexity into the framing, the design, and potentially cost as well. But ultimately, what won out was the is it this button?
Yeah, the fun button.
Fun button. The fun button. This was where the fun was. So this is where the decision was made. So ultimately, you can think of this structure as a self-contained tennis racket without the benefits of having the shape of a tennis racket. So we basically want to have a self-resolving structure. One of the issues we had with this was the fun buttons here. Was the bottom beam here. We were quite limited on the opportunities to support that. So we looked at building a truss at the bottom. The issue is also the program at the bottom. We had to keep this relatively clear. So ultimately we needed to come up with something. It looks like structural gymnastics, but it's kind of required because of the program directly underneath. And we also have an opening to deal with as well. So ultimately we went with a triangular frame with a little bit of structural gymnastics at the bottom, just because we couldn't get regular support along this edge. So the design intent is a triangle. It is 40 meters wide and 30 meters tall. It inclines 35 degrees. We use 2 rows of horizontal cables and 8 incline cables, and in total there are 20 pieces of glass. The largest piece of glass is 12 meters tall. So in terms of how we stop this from falling out of the building, you can think of it as being supported along the bottom and then pivoted along that bottom edge and essentially restrained from falling out from a number of supports at the top. So here what we're trying to do is we're trying to minimize the impact onto the that main primary structure. The glass itself, so obviously it's inclined, there's permanent dead load, always wants to try and fall out, but as well the pieces of glass themselves are skewed, so they also want to fall within their own plane as well. So quite a lot of things happening here. And we go into some more detailed analysis, and what we need to do is to go into global models and then into local models. So the issue we have with this type of structure that we wanted to understand from a global perspective is that we have a very stiff tennis racket along the edge, but then we have a more flexible net of cables. So you can see here with the red and pink panels, those panels there, they're supported on one edge by the stiff tennis racket, but on the other edge, they're supported by a more flexible cable. So this causes a warping issue that needs to be dealt with. And we end up analysing all the glass panels just to understand stresses. And here it becomes a picture of all the different restraints we need to do. Then we start looking at details. We have toggle fixings. So the outside face is essentially all you see is a 25 mil structural sealant. same detail here. And then what I said before about that special edge condition, we start introducing springs along those edges. This allows those panels to breathe, allowed to move. These are the detail at the bottom where we jack the cable against that bottom beam, and then how we attach that overall tennis racket back to the parent structure. We want to let it move and to limit unnecessary forces onto that parent structure. So whether you believe God is in the details or the devil is in the details, you have to look at these details in these kinds of complex structures. So I'll give you back to Vivian.
Oh, okay. All right. Yeah, no, close it up. Ooh, -10. Yeah, so, we're hoping that you'll come visit when it opens later this fall. Come enjoy a view from the cafe. And thanks for everybody's time today.
Thank you, Vivian, to showing us, how to design a building, to bring the X feature from external to internal. We would like to introduce the next speakers. Eric is a project manager from Smart Class Division, AGC Asia Pacific. Talk about the design building with VIPB from concept to compliance.
Good morning, everyone. Thank you for your time. I'm Eric from AGC Group. So today my topic is design building with BIPV from concept to compliance. So this is agenda. So totally we have 5 parts. First is introduce ourselves. AGC is a Japanese company. We have business in the glass, electronic, chemical, life science, and ceramic. So we have business in America, Europe, and Asia. And we have our headquarters in Tokyo. Yep. So this is a photo to show AGC BIPV business. We have 4 pillars: BIPV glass, facade glass, and the interior glass, and the industry glass. So those are Japan bullet train. The window is supplied by AGC. Yeah. So we already have more than 100 years history for the glass industry, and for the BIPV we have 25 years experience. We have a factory, BIPV factory in Korea, Japan, and Belgium. So far we already finished around 400 BIPV project worldwide, and we have a local office in Hong Kong, Taiwan, and other Asia country. And we also provide the technical support for the local BIPV project. So what is BIPV? So simply say is a 2 piece of the construction glass laminate the solar cell in twin, and we also can do the IGO and the coating for BIPV glass. So what's the difference between BIPV and PV? So first, BIPV is the facade glass. So normally in terms of the Hong Kong, it's easily like a 10+10 to within the wind load. And also, or it have to meet the architect requirement to like shape, glass size, and thickness. So we also have to achieve the optical data like a SCU value, and we have to purposely adjust the cell-to-cell gap to meet this light transmitting requirement. That's why the BIPV normally the efficiency is slightly less than the PV product. So motivation to use a BIPV. First, it can generate the green energy. Second, it can improve the optical data like provide the shading, improve your SCU value. Of course, it can contribute to your LEED beam certification. And from the long view, it can generate the power to offset your electrical bill. And the maintenance method is similar like a facade glass. And the last point is in some of the country, for the new building established in the downtown area, the government will have a requirement to have this certain percentage of the on-site renewable energy. But the tall building, the roof is a limit space. So naturally, architects start to consider use a BIPV for the building facade. Engineering consideration of the BIPV application. So before this topic, I want to share to finish a BIPV project. We have this three-party working together. AGC as a BIPV supplier. We have a close working with a local facade partner in terms of the facade design, how to run in the cable inside the frame. And after the BIPV glass installation, we will hand over to the electrical partner. They are running the cable to the inverter and make the whole system connect to the grill. So what kind of engineering support for BIPV project? We have a two-stage, concept design stage and the project stage. So in the concept design stage, we provide this project assessment. What is a BIPV installation, position, facing, degree, the glare issue assessment, and also we do this analysis like a cell layout, aesthetic, optical data, what is the power estimation, and also like a frame integration, how to maintain the BIPV facade. The last part is number 3 part is permit clearance. We will support you do the local government regulation fulfill like a test report, fire safety. So I will use the next slide to explain you more for this topic. Then in the project stage, we have working with a local partner and a contractor, like facade electrical design, schedule monitoring, quality control, and also for the first panel installation period, our engineering will visit the site to support the panel installations. So BIPV is a cross-function product. So one side we have to fulfill the electrical requirement, another side we have to fulfill the building requirement. For electrical wise, popular is like a REC 61730, but this certification is designed for the conventional PV with a fixed size, fixed power output. But for AGC, we have to working with a lab like a TUV Greenland to come out this family certification to cover the different size, thickness, shape. Yeah. So in terms of the glass, building glass, we also have to fulfill like an impact test and the durability test. Of course, when the glass used for the facade, we have to meet this fire safety requirement like EN 13501, MSD 23. AGC offer this Class A panel to the market. We are also working with a facade company for this PMU test. Yeah.
Okay.
So next topic is the fire safety. This is a popular topic in Hong Kong. Last year, we realized the regulation is the update about the year 13501. Yeah. So different countries will have a different regulation. So people, the main topic is how to prevent the fire happen. If fire happen, how to reduce the loss. So I will explain this point in 2 aspects. One is the material level fire safety, one is the system level fire safety. In terms of the material level, I will share the regulation in Singapore and North Korea. Yeah. In Singapore, we have this fire regulation set up by the government agent, SCDF. So it category PV, BIPV into wall mount, roof mount, and the intergrid. So we have a fire safety regulation for the panel. And of course, we have this electrical test in terms of the hotspots, bypass dial. And for the cable and the junction box, we also have to pass the fire test. So the challenge part is how to let the test report cover different type of the BIPV. So in South Korea, they have their national BIPV requirement in terms of the material. But recently, more and more projects start to do this full-scale mock-up, which is a 2 to 3 story with not only BIPV glass, but also the support frame. They are the bending brand at the below. So the lab will observe the behavior when the fire case happen. But honestly speaking, for BIPV, we cannot say is a full non-combustible material. So everybody knows this interlayer, no matter PVB or EVA, it's easy to burn. So we have to enhance fire safety from the system level. So this is one of the example, like we are working with the architect to set up this sprinkler system at near the BIPV area. So the middle photo show the cladding system. Normally we will set up this fiery bore or fiery wall behind the BIPV panel. And the last one is one of the project keys, because for this FIP, the fire escape opening panel, we try to avoid the interface between the BIPV facade. For this project, we are discussing with the QP person, try to shifting this FIP panel from the north to the nearby east and west facade. So different type of the BIPV AGC, we have 4 different type of the BIPV product. So first one is the clear glass, front is the low-end glass. We have a solar cell in between. We can do coating and the ideal glass. And the next one is this black color cladding system, use the cladding of the facade. Number 3, we will, based on the architect, provide the color code to do this customization color panel. And of course, we can do the pattern design, like architect want like a marble image, brick image, or they provide a company code photo image. We can do the BIPV accordingly. So last part is a BIPV, AGC BIPV project sharing. So we want to share BIPV is not only for the building facade, it also can be like an infrastructure facility, like a BIPV tree in the park, and also there's a north barrier, bus stop or substation. So this is one of the project in Hong Kong. It's a skylight system. Last year, we also finished one project in Hong Kong. You can see this is a renovate project. The top of the building show you the conventional skylight and the walkway. And we're working with a local partner to renovate this skylight into the BIPV skylight and walkway facade. Same project, we also do the facade change. We're working with a partner to make this cladding system. You can see the bottom is black color, gray color, actually the BIPV claddings. So this is a Hinwa footbridge project in Hong Kong. And this is one of the net zero building project in Japan. Last year, my team also finished another net zero building in Singapore. It's a private school. So we have this skylight BIPV at the rooftop, this garden area. Because the roof garden have a tree, so on top of the tree for this BIPV panel, we purposely reduce the solar cell dense to allow the more sunlight reach the tree area. But just rely on the skylight is not enough to generate the power. So we also install this horizontal fin BIPV at the north facade. And this fin also provides some glare control for the building facade because they are the residential building opposite. So this is one of the university project in Singapore. Last year, this is a super low energy. Architect have a high requirement for SCU value. So we have proposed this ideal glass with a softer coat. So the total thickness of the glass is almost 50 mm. The glass size is 1.5 by 2 meters. So each panel is almost 250 kg for this project. So some of the other projects in Japan, Morocco, so the photo on the right side also show we can renovate the conventional walkway into the BIPV walkway. So this is a project in Belgium. Actually, this is a warehouse near the Belgian train station. We try to change the old facade into BIPV. We have to customize this odd shape BIPV panel to meet the roof shape of the building. And this is some project in Australia, Norway. This is a double skin facade, and also the project in France. in Russia, Belgium, and we also have this black color cladding project in Netherlands, Norway. Yeah. So for the pattern facade, you can see the photo on the left side. Actually, this TNO is a BIPV panel, which is present this company logo. We also have this shell building, this red color, yellow color. The cladding actually is all BIPV panel. Yeah, some project in Korea, this tree image cladding is a BIPV panel. We also have this blue color cladding system, also belong to the Korea project. Yeah, so this is the last page of the my presentation. What is the AGC strength? We already have 25 years BIPV experience, and we have 400 projects worldwide, and we have a local office to support your BIPV. We also glass factory provide the technical support. Of course, we have the warranty for BIPV panel. Yeah. So we have a booth outside. If you have any question about the BIPV, feel free to approach us. Thank you for your time. That's all.
Thank you, Eric. I think the BIPV panel is getting more mature in the market. I think most of the developers are getting used to use BIPV panel for now. So we would like to introduce the next speaker, Sunnie, downstream marketing manager from Kuraray. Thank you.
Good morning, everyone. I want to firstly thank the Zak for having me here. I'm really deeply honored to be with you today. My name is Sunnie. I'm located in Shanghai, working for Kuraray AIS division. I saw there's many renowned architects and designers here today. And I'm not sure if you often have the same concerns because I have many times been asked how to select reliable and high quality laminators. And how can I know if my project used authentic center glass interlayers? With these two questions in mind, we are here to introduce our Certiply technology and QL program. But first, let's ground ourselves on the basics. Okay, Kuraray AIS Interlayer Division is leading global specialist in the development, manufacture, and the supply of the PVB and the center glass interlayers for laminated safety glass applications in the architecture and automotive and marine industries. This is built on a global network with more than 50 production facilities spreading more than 30 countries around the world. Our advanced interlayer solution division is responsible for the development and production of the interlayers for the safety glass and counts more than 900 employees over the world. And we have 6 production lines, multiple R&D centers, and service locations provide local support for our valued customers and project stakeholders. Okay, let's first watch a short video to get a general idea about Certiply technology.
Now, Sentry Glass Interlayer can carry a digital fingerprint, a unique identifier that secures its history, quality, and journey. From our factory, your site, nothing is left to chance. At the core is Certiply, Kuraray's blockchain-based tracking system, a decentralized tamper-proof solution that links data in chronological blocks. Every movement, every update, every hand it passes through is recorded and encrypted. Once created, the token becomes a living part of your project, moving across stakeholders in real time. It's not just traceable, it's visible, verifiable, and transferable at every stage. It gives you confidence in your material and proof for your clients. Discover how Certiply is shaping the future of laminated glass.
Okay, let's go deeper. A supply actually is a blockchain solution, a distributed ledger, a decentralized, immutable database, where records or called blocks are securely linked using the crypto hashes. Each block contains a timestamp, a transaction data, and a reference to the previous block, forming an unbroken chain. This design ensures the transparency, security, and traceability. So in simple terms, Certiply is a system for replicating and synchronizing the digital data across the multiple locations, secured by the advanced mathematics. It eliminates the centralized intermediaries, reduces the fraud, and creates a single source of truth for all the stakeholders. So how does Quarry use the Certiply for this technology? Every batch of the materials we sold to the customers represent a token. This token is a digital twin of the physical batch. And with this batch produced, Quarry creates a unique token tied to the batch number. This token carries the metadata such as the production date, material specifications, and ownership history. As the batch moves through the value chain, you see from Quarry to the laminators and the system manufacturer, installers, and end users, this token will transfer digitally. So, what does a crypto token look like? Here is an example. Each transaction updates the blockchain ledger where recording who transferred the token, for instance, a laminator, and when the transfer occurred, and what status change occurred. For example, it's processed or shipped. This process mirrors the physical journey of the batch, ensure a real-time visibility. Okay, let's quickly go through the process. To participate in the Quarry blockchain network, the customer will follow these steps. The first is to access the Quarry product path portal or scan the QR code here provided, and then download the MetaMask. MetaMask actually is a browser extension wallet that will interact with the blockchain. And after that, we will create a secure password and a recover phrase. Next is to enter to the link, the Quarry product path, and then follow the menus for the further steps. Yeah. You may want to know what benefit of Certiply we can gain from. Obviously, it will enhance the traceability. Every stakeholder, from the laminators to the architects, they can trace the batch journey in real time. This transparency reduces the disputes or ensures the compliance with the quality standards. And there's the fraud prevention. The Certiply's immutability makes it nearly impossible to alter the records. So tampering the batch data would require hacking the entire network, which is really infeasible. And also, the automated token transfer replaced the manual paperwork, accelerating the process like the ownership transfers and the certification checks. By the digital records, Quarry reduced the paper waste and the carbon footprint associated with the traditional tracking methods. We want to say Certiply is not just a technical novelty, it's a paradigm shift in the supply chain management. By minting the tokens and enforce the role-based access and enable the seamless transfers, We empower our architects and the stakeholders to collaborate with more efficiency and trust. Okay, think of Certify as a digital passport for every Central Glass laminated glass. Quarry's Q&A program, Beyond Traceability, is our quality command system, ensuring the same excellence from the material sourcing to the final delivery. Q&A stands for the Quality Network of Laminators program. The core purpose of the Q&A program is a long-term dynamic quality management system. It's designed to ensure the consistent and high-quality laminated glass production and improve the yield rates and reduce the costs for the laminators. And we will also foster the collaboration and the knowledge sharing across the supply chain. Ever since the 2012, this program has been delivered a consistent performance for more than a decade. We've now grown our certified partner network to 64 laminators, with many top-tier players on board. Look at this regional distributions. We have 20 lines in South China, 18 in the East China. In North China, we have 12, Central China 5, Southwest 5, and also Taiwan have 4 lines. Okay. How to become a Q&A member? The first is about the business recognition. It's focused on the gathering the laminators information, conducting on-site inspection, and enhance equipment and management practice. The second is a technical audit. We'll review the facilities, oversee the sample trials, and provides technical training and approve the samples with 0 defects. Then lastly is about the Q&A maintenance, includes the quarterly testing of samples and the regular site visits, and conducting random technical reviews to ensure ongoing compliance and quality standards. And in order to keep pace with the changing market needs, we are now taking our Q&A system to the next level by focusing on 3 key important areas. It's the facility, stability, and the reliability. So the facility means complying with the requirement of the factory environment and the production equipment that's specified in the Cordis glass production guidelines. And the stability is measured by the mega projects or the processing frequency of the central glass that monitored by the result of submitted samples. And the reliability means always adhere to choose central glass as the primary material for the ionomer interlayer applications. And each year we will conduct an evaluation to ensure our members meet these 3 essential standards. And importantly, this system includes a dynamic adjustment to all the memberships to maintain a high level and commitment. Also, the benefit for this rating system is quite substantial. Here, the 2 and 3 stars laminators can enjoy the co-marketing opportunities and blockchain technology. And we will also give the financial support for the logistics and also technical support. Ultimately, this initiative is to empower our customers to make them be prepared for the competitive marketplace. Together, let's embrace the central glass Q&A rating system and working towards for our collective success. Okay, thank you for your time and attention. It's been brought to you by Quarry, and underlined commitment towards serving the ever-changing demand of the global glass industry through our innovation and leadership. Any of you have questions, we can discuss offline freely. Here is my contact, and you use your camera to scan it and add to your contacts. I'm more than happy to receive your emails and answer your questions. Thank you.
Thank you, Sunnie. For sure, if you have any more questions, to ask Sunnie, I think, please visit the booth during the networking section. So we would like to the last speaker of this section, Simon, from Technical Director from Far East Façade, talk about the complex curtain design and intelligent production. Thank you.
And good morning, ladies and gentlemen. I'm from Far East. I think my presentation has several parts. And firstly, I have introduced something about the Far East. And we also have some case study for Henderson, Opal, and Galaxy Phase 4s. And we also have the photovoltaic panel. Firstly, we introduce Far East. And we have 5 most achievements. And the iconic tallest building, the most complex project, and large construction projects, and the faster project and the highest quality projects. And we have about 56 years experience in Hong Kong. Okay, we installed the curtain wall for Burj Khalifa. This is a world tallest building. And we also have another project, one block in West Toronto. This is the tallest building in North America. It's under construction right now. And we also have one project in Chile. And the complex project, we just completed Henderson. And after the Henderson, we also have the Opal and the Tower C. That is more complicated than the Opal. And the large project in single contract, and we have the Galaxy Phase 4, and this is about 7 hotel tower with a huge podium, with the signature of the theaters and the dome skylight. And the faster project, and they have a 6 3-star hotel block in Shenzhen. It's a quality hotel. We complete about 140 square meters in 100 days. And the highest quality project, almost 80% of the Apple shop done by Far East. And this requires very high qualities. And in Hong Kong, we have many projects in residential. For the Kai Tak runway, we get about 8 projects out of 10 residential development. For commercial building, we complete 2 projects in Central and 2 projects in Tai Po Place. And for government project, we have the cruise terminal, and some for the hotel project, we have the Server Hotel. In Hong Kong, the government have a 10-year hospital development plan. We get 4 projects from 12 hotel. And for the government project, we also have the cruise terminal, immigration headquarters, and the Kai Tak indoor sports center. In Macau, we have 6 luxury hotel projects completed. And internationally, we have projects in US. And from West Coast, we have the Las Vegas project, and we also have the Palazzo. And in East Coast, we have the Hudson Street. And one of the projects is from Hong Kong developer from Swire. This is Buckle City in Miami. And in Canada, we also have a lot of projects for major cities like Toronto and Vancouver and Montreal. London, we just finished the project in central London. There's say One Elephant and Victoria Street. Australia, and we also done some landmark project. It's about more than 200 square height. In Dubai, we complete the Burj Khalifa and also some of the two projects in the major city. Japan. We also have two projects in Tokyo. This is a Tokyo station. And Singapore. We also, last year, we go back to Singapore. And we also have few projects like the Marina Sands we have completed. And the new project we have Shevonne, that is a double curve cladding project. And also Central Mall. So, we go back to complex facade design and into the production. I think a few hundred years ago, this is a very complex project from the architect. I think the architect draw the drawing. It is actually it's an artwork or a sculpture and relies on the craftsmanship to build the building. And by the year 2000, the architect also play around the double curve. But we did not have a technology at that time. We using the triangular or the segment gas to build up the curvature. So you can see the reflection is not smooth. And nowadays, I think the technology and the computer advanced program, we can use the smooth of the double curve facade. And we finish the Henderson afterward, and we have more complicated project of the Opal and even the Tower C in Qinghai, Shenzhen. This is a case study for the Henderson, okay? I think this Henderson project, I think, is a first unitized double curve facade in Asia. I think I saw some of the Michael saying that they have another double curve project. And the facade area is about 25,000 square meters. And this is some image of the projects. So the double curve. And I think at the beginning of this project, and they have a debate between the client, the architect, and consultant. And think about whether the double curve unit triangle can be feasible or build buildability. So at that time, the client hired few criminal contractor to doing the installation mock-up. And at that time, we are one of the installation mock-up supplier. So this is a photo how we build the mock-up here. And this is a project, and we analyzed that we have about 800 panel is a flat panel. The other panel is a double curve or conical or double curve. That means about 60% is a double curve panel. And all the panel is not repeated, only 20% is repeated at the rear side of the building. Okay, for this, for the complexity of the project, without the BIM, we cannot fabricate or manufacture our curtain wall. I think most of the architects, they are using the Revit for the building information. But for this project, the architect using the CATIA. And in our side, we're using the vinyl to doing all the BIM. And afterward, we're using the vinyl model to do the fabrication model for direct import to our CNC machine for fabrication. So, the DFMA is a very good principle for current fabrication. This means design for manufacturing assembly. We need to consider at the beginning from the design up to the installation. So from the design, we must have the BIM. And from the BIM, we need to have a fabrication model for have a more accurate production. So for the fabrication information model, we have the 3D model and digital rolling of the curvature of the machine. The machine code can direct input to the CNC machine for cutting drilling, and the digital assembly, and even after the finish, we have the 3D scanning to calibrate the quality and from the quality assurance. So we also using the parametric design for the fabrication. And they have advantage of the parametric design, and it's easier to capture the family part and automatically capture the design change, and even excellent to integrate to the manufacturing process. We also using some of the plug-in program for the parametrics. So, and we can after we can draw from the drawing, but how we can produce the actual products. And at the beginning, we finding all the machine, how we can bend the profile, our mullion and transom. Because there's a special curvature, we had to bend the mullion in 2 directions. Even you need to twist the mullion to follow the curvature of the glass. So we work together with the bending machine supplier to have a development of this turning table for making the mullion twisting. Here's some videos showing how we bend and twist the mullion. So this turning table is designed to with the supplier together. So, and from the parametric design, we make use of the fabrication, and we don't have any, because our labor did not have any paper drawing. We just have a BIM model from the computer. So we use this fabrication model is directly input to our CNC machine to making the drilling of the hole and cutting the notch on the mullion. So, and for the accuracy and preciseness of the fabrication, we cannot using a traditional method to measure and checking the tolerance. So we use the 3D scanner to calibrate the actual product, whether they meet the tolerances. This is some of the scan result. This is a scan result of the whole kernel unit. So this is a site scanning and how we install it, and then finding any deviation from the BIM model. So I have a video showing how the process of the whole fabrication.
Dimensional space composed of X, Y, and Z axes. When we place a straight profile, we can regard it as a flat straight line. At this point, if we apply a force along the X axis, it becomes a single curved profile. Then, if we apply a force along the y-axis, it will have curvature in both dimensions at the same time, which is double curvature. This profile has now transformed from a straight profile to a double curved profile on the basis of the double curved profile. If we apply a clockwise twist along the z-axis, it will become a double curved twisted profile. Why is it necessary to create a double curved profile? In building facades with curved glass, we encounter various types of curved glass, such as single curved, regular double curved, and special double curved surfaces with unequal top and bottom arcs. Therefore, the profile processing requirements vary depending on the type of curved glass. Straight profiles cannot directly match curved glass. For single curved glass, the straight profile needs to be bent along the x-axis to achieve the required curvature. For double curved glass, the straight profile needs to be bent according to the curvature of the glass, considering the force requirements along both the x and y axis. when dealing with special double curved glass with unequal top and bottom arcs because the two sides of the glass have a certain angled tilt from top to bottom. Two-dimensional bending alone cannot perfectly fit it. We also need to rationally deform the profile's cross-section along the z-axis. After precise bending and twisting, we can then combine the profile with the glass. The double-curved surface of a building can be broken down into many smooth and continuous units, each with a different region. Therefore, the requirements for each profile also differ, which is the technical challenge of double curtain walls. How can the double curvature twist of profiles be achieved through a roller bending machine? The double curvature of the profile is formed by a customized mold with an inclination angle on the roller bending machine, creating a fixed angle. This is achieved by using the drive roller and the fixed roller to form a flat arc curve. Then, the inclination angle and flat arc curve are used to realize the diagonal roller bending of the cross-section, achieving the double curvature effect. Finally, twisting is performed using a fourth axis fixture to achieve the effect of profile double curvature twist. When we open the architectural skin model in 3D software, if the building facade consists of a series of rectangular glass panels arranged in a short, long, short pattern, we can select two panels that are identical and perfectly overlapping. In this case, the design process allows us to directly copy multiple identical rectangles to complete the facade design. However, when the facade consists of several curved panels forming a double curved wall, the challenge changes. If we use the two-point alignment function in the software to compare any two curved units by overlapping their equal length edges, we quickly discover that the two curved glass panels cannot fully align due to differences in curvature. As a result, in double curved curtain wall design, the direct copying of units becomes a significant challenge, requiring specialized solutions to ensure accurate fabrication and installation. In the profile processing workflow, traditional straight profiles are placed on the machining center as linear elements, making them relatively easy to fix and position. However, when processing a hyperbolic twisted profile which follows a spatial curve, positioning becomes significantly more challenging compared to straight profiles. If the placement is not precise, drilling operations may result in misaligned holes. Furthermore, if the bending process in the early stages produces a deviation exceeding 3 mm, subsequent steps, such as cutting, drilling, and assembly, will be impossible to carry out. Therefore, tolerance, control, and accurate positioning are the primary challenges in the production of our twin bridge curtain wall units. To overcome these challenges, we can import the parametric model into the machining center in advance. Before processing, we utilize 3D scanning technology to capture the actual profile model and compare it with the BIM target model. This ensures the positioning is accurate and the drilling points align correctly. By integrating 3D scanning for tolerance, verification, and precise positioning with automated machining, we achieve a seamless fusion of technology and architecture, creating the curves that define modern cities. The majority of Henderson facade consists of double-curved, unitized panels, demanding extreme precision in aluminum profile processing for special double-curved glass with unequal arc lengths. Each unit varies in shape and requires precise bending. The curvature directly affects processing and cutting accuracy. If the cutting angle deviates over 0.3 degrees, assembly errors amplify, preventing proper profile fitting and affecting installation. Therefore, ensuring high precision control is crucial.
Okay, we also have another case study for the opals. After the successful of the Henderson and the same architect Zaha did, we get another two projects in some time. And I think the challenge is more than the Henderson. Opal, the area almost 4 times of the Henderson, and the panel number is also 10 times more than Henderson. And also, because they kind of want to save the money, they use the cold band gas for that. here is our BIM model we're using to classify the system for the projects. And this is a mock-up we built it before the tendering. And for this project, we're also using some precision steel, because in some area this is a very high span, is structural steel, and that here we also have some opening for the TMU. And here is a cold band gas. So we make the curved gas and bend onto with the gas out there. And this, we working together with the university and to calculate the bending stress induced by the long terms. So here is some tests on our factory for the cold band gas. And this, I think for the whole project, we have some area using cold band gas. So for each gas, we need to have a finite element calculation. We're using a plug-in program linked together with the BIM and the finite element to calculate every pieces of gas in terms of the wind load, structural, the bending load, the cold band load, and the thermal effects. So using BIM and finite model structural calculation together. And another case study for the Galaxy. I think this is a largest project in Asia. The contract value is about more than 2 billion Hong Kong. It's 7 towers of hotel, and they have a signature of the theaters and the dome skylight. They are using the UHPC panel. And this is our theaters project. And they consist of 600 different cone profile unit here. There's also the video here. And we make some comparison between the BIM model, the actual work, and the skylight of the dome, also the video. Okay, and for this dome skylight, we're using the ultra high performance concrete. And the strength of this UHP panel almost 3 times higher than the concrete. And it is more flexible for forming the different profile architecturally. And it's really high performance for your structural. And we can use a thin material. And for the durability of this UHPC panel can withstand existing 100 years for the long life. So we also have a photovoltaic panel in our factory, and our photovoltaic panel can have a different color to stimulate the aluminum panel cladding. And we also have some stone pattern or the wood pattern on the photovoltaic panel. And this is some job reference of the photovoltaic panel in China or in Hong Kong. Okay, and we are Far East, and we are not just a general contractor or the manufacturer. We embrace the advanced technology, science, and the engineering. So thank you for this.
Yeah. Please stay on the stage. Thank you for every presenter for this section. May I invite all the presenters under this section to come on stage to have a quick group photos. So good for everyone to come back. For this section, we have the first speaker is Andreas, the Managing Director from HS&A, to talk about, specified standard is not good enough.
Specified standards is not good enough. What does that mean? Basically, I thought, when Saks called me and said, can you speak at this conference? And I said, yeah, I can do that. And I thought, oh, great. First thing I thought is this new arena we're putting into Doha, 60-meter free span. Let's talk about that. And I said, no, that's can do, cannot do, shall not do. Let's try to use the Façade conference for something that is different. Let's try to put something here that is not putting out how good we are, but where the whole of the facade industry can be if we wanted to go there, and if we have a concerted effort from architects who are here, developers who are here, facade contractors, suppliers, glass suppliers, everybody. And then I thought, okay, what is happening in our industry right now? Our industry is having a problem, not that much in the commercial projects, but more in the residential projects. Because the residential projects are becoming more and more big pieces of glass, big pieces of sliding doors, large expanses of glass, and owners who are not professionals, they just want to have and enjoy their place. So what we have in our industry is this. We have ASTM 1036, 1048, and we basically tell people how to look at glass. And this is great as long as the people are professionals, and the glass is basically changing hand from one professional to the next professional. Everybody happy because we have a fixed standard and we can work with that. Income, Mr. and Mrs. new owners of the flat. And what we have is they're not professionals. They're standing there like this, 20 centimeters away from the glass. And we as facade professionals basically have to look at and re-look at what we are doing. And this is what we are getting. We're getting the ambulance chases. In Hong Kong, at least, I don't know, anybody else comes from other jurisdictions, maybe it looks different, but this is how handover of flats in Hong Kong looks like. And people basically demand perfect glass. Don't define what perfect is, but perfect glass at least is not what you have here with scratches and all the rest. So it is driven by two very different things. The one is the aesthetics. The aesthetics is more an architectural thing. It's like anisotropic glass or the so-called leopard spots, or then we have scratches, and so the owners basically want to look at what can be done, what can be not done. And some of these places are, as I said, they are high-end properties, and owners are basically looking at high-end properties in a different way as they look at any other thing. And it's an emotional attachment that these people have to their properties. And this is what happens. So we have people going into AGMs and often new ownerships, and they're basically forming WhatsApp groups and WeChat groups and whatever. And we are being put into position where we have to look at what we are doing in this industry, because this is not the way we can basically sustain this industry, and it will not be sustainable from architecture, from facade, from developers. It's not. And to go into these meetings and say, oh, you have to look at your glass according to C1036, stand 3 meters away and look at it against the white background, is not going to be the right answer for somebody who just shelled out $250 million for a flat. So we end up with doing all this, and we're basically looking at the root causes. And the root causes we have is that somewhere along the production line, the whole thing goes wrong. If you were to have a new Apple phone with scratches on the screen, you wouldn't accept it. And very much the same happens here. Somebody paying $50 million, $100 million, whatever, for his flat is not going to accept it. So I do think what we have to do is, as an entire industry, we have to just look at how we can go and adapt. And what is the adaptation? Where do we go with the adaptation? Because what we don't want is, we don't want to go and adapt to new rules and regulations. We basically want to go and adapt to a certain part of the industry moving. It's a certain part of the industry that moved to, here we go, to large pieces of glass. It's a certain part of the industry that moved to very wide glass, 20 meter by 3.6 meter glass. It's not everybody, but certain people saw a business model there. And this is why what I'm actually advocating here, that we should be looking at where do we need to modify a business model to match what the expectation is, rather than trying to make people to adapt their expectations to what we deliver them. Because what I don't want to do is, I don't want to advocate that we have enforced changes to the ASTM, make it more stringent. This is not what I want, because what we want is that we basically are doing better. You want to find a scratch on here? Probably not, because it's unsellable. It would become unsellable. But in our industry, we are basically saying, oh, you have to accept that. And no, it's not. I do think we just have to put a second track into our industry that says, no, you don't have to. You have to maybe shell out some more money. It may be a different way of operation. It will go according to that. It will basically be the glass suppliers having to play their role, because the glass suppliers are the first ones to do it. The first ones to basically touch the glass, from float line to cutting, to grinding, to tempering, putting insulated units together. That's the glass industry. And then we have the glazing contractors. Over to you, Simon. Basically, where we say we have to do it right. So we get the perfect glass, so we have the perfect glass into the frame, and we move the perfect frame over to the site. And I do think then it is to the next stage where we have the main contractors, the developers, to have the perfect frame to be perfectly installed. If I have a pile of rubbish about that high on each floor, obviously the workers cannot do anything. If they can just trolley it to the edge of the building and they can nicely bring it out, it's a lot easier. It will cause a lot less damage. And we have to look at how we do it. I do think that's I was basically saying glass suppliers, the contractors, the developers. I do think all of them, all of us in the facade industry have to have a role here. It is not a single person that we can look at and say, it's all your fault. No, it's not. Say, for example, I was talking to some people who were doing protective films during the production of a TV. just the standard TV that you're buying, they're using 12 different types of film, which they always take off, put on, take off, put on at each of the production stages. Do we have to look at something like that as well in our industry? We may have to for certain projects. That has to be one of the things that we have to look through and find the ways to get it. Because Apple and Nokia basically define what can be done along the quality chain. They define what we are expecting. And the production will be the same thing. The production in our case has to be the same thing, that we define the end product to the expected and required standard. And that, as I said before, will be all along the value chain, from the float tank to the installed unit on site that we have. And Michael, in the very beginning, was basically having this approach. He is basically saying, okay, or a part of that approach, we take the idea of the architect and we bring it all the way to production. We don't have tenders, we don't have changing hands of the intellectual ideas in that process. He is still going out and having fabricators and still going out and having installers. So maybe we have to even rethink that part of the delivery strategy. But I think it can be done. I just took this one here, a small private villa. They basically, and I know the owners, they basically did exactly this. They looked at their glass and glazing at every stage of the way, at every time the corner changed. They were there, they had their people there, they looked at it, and they got it installed in a way that they wanted to see it. And I do think that is why I want to take not the whole industry, because I know the whole industry is not interested in, the whole industry is not ready for it. But I do think we can take a part of the industry, a small part of the industry, to producing a high quality, high-end product that is more than what we are offering the purchasers today. Thank you.
Thank you, Andreas. I think, it is quite related to all the industry stakeholders and contractors, consultants, architects, developers to think about it. So I would like to invite the next speakers, Edward, Associate Director from Zaha Hadid, Architects, talk about the International Gateway Center in West Kowloon. Thank you.
Okay, thank you. Good morning.
Thank you, Edward, to give us a presentation about. It would be quite challenging, for the aluminum features and what interfacing, and looking forward to be complete version. So we would like to invite the next speakers, Joan, from a consultant from sedak. The Henderson. The topic is the Henderson and floating architectural possibility through flat and curved glass.
Okay. Well, very happy to be here today in Hong Kong at the Zak. Always an excellent platform to catch up with people and to do networking. So thank you to the organizers. We have prepared a presentation that highlights on the glass that we produced and delivered for the Henderson Tower, designed by Zaha Hadid. And so we will focus on that, and we will also do a short introduction about us so that you know where we are based and what we manufacture. But basically, we will talk about the glass for the Henderson, and we will finalize about, why not, what's next after the Henderson, where we can see some very complicated geometries in glass. So about us, I mean, sedak is a company based in Germany, northern part of Munich. We have 2 factories, headquarters in Germany, and another one in Italy, close to Venice, where we produce glass for marine business and trains. But in Germany, we produce oversized glass up to 20 meters, curved and flat for architectural business. The company was actually was actually founded in 2007, so not that long ago. So it's a quite young company, but if we take a look to the portfolio of projects completed by sedak, it's amazing. And one of the first orders that the company had to face was the amazing and singular Apple campus in Cupertino, in California, by Foster & Partners. So at that time, sedak had to face delivering manufacturing and delivering panels that nobody else in the world was thinking of. So 14-meter-long curved glass, bent without temperature, bent during the lamination process. But sedak, here we can see the headquarters in Germany. I mean, was basically founded to deliver all those glass configurations and quality that nobody else in the world was willing to touch. So glass basically for Apple-type jobs. As we focus on quality, I mean, it's super important, as you know, to concentrate the most of the processes in-house. So we like to control all the processes. Since the very beginning, I mean, we don't take care of raw materials so that we get in big sizes, but we start by cutting and grinding and printing the glass and doing the tempering, the bending, finalizing with lamination, double glazing, triple glazing. Even we do the bonding of glass to frames if our clients require. But this is, I mean, integrating the whole production under a single roof is basic to be able to control the quality that we deliver. In terms of sizes, I mean, we do flat and curved glass up to 20 meters. So if we compare that, I mean, it's very easy to talk about sizes, but if we compare that, we put that in context with what we call a European jumbo size, 6 meters, which is already huge. So today we can deliver more than 3 times larger than European jumbo. So we can process that either at that size, at cutting and lamination and tempering and bending. So the whole process we can control. And what best that a nice project, a little project, so we don't have to think of big towers or big challenges like the Henderson. I mean, sedak is also very interested in little projects that have a high added value, like this one. This little project in the UK that we just delivered, it's double glazed unit in 20 meters, 2.8 meters in height, double glazed, with a very nice detailing. As you can see the detail, vertical glass double glazed, and the roof sitting on the vertical glass. On the left, you can see here, these blue squares are glass spacers. So to make it more complicated, first, the roof has no support. There's no glass support. There's no metal beam supporting the roof. That spans 6 meters, so a jumbo size. And even to do it more complicated, we have not a normal spacer, but a glass spacer. So here we can see the 20-meter-long piece of glass being packed in our logistics department. But let's focus on the Henderson, which is the main purpose of the presentation. So here we were approached logically by the project team, and in the end we collaborated with 2 main contractors, Façades and Sille. Façade took care of the main curtain wall, and we were very happy to collaborate with them on all the flat and curved glass, and Sille delivered the very top banquet hall and the ground floor level. So if we go step by step and we take a look to every single composition, at the roof of the banquet hall, we have a double glazed unit with a combination of solar control and high selectivity coatings, but also an anti-reflective coating to the inside, so to avoid double reflection. Very important to the client in this case. So here we can take a look to the roof with the glass fins also delivered by us and this automatic shading system. The vertical facade at the banquet hall is quite unique. Structural glass, no support behind the glass, no mullions, no glass mullions, nothing, just structural glass. And this is why Ujjal O'Callaghan engineered a wall composed of 6 layers of 12 millimeter. So here we have fully toughened glass, 6 layers, with 5 layers of structural sentry glass interlayer. So when we think of something like that, 6 layers of such a thick glass ply, we can think that the glass will look distorted. That by adding so many interlayers, the glass will look a bit hazing. But if you have a chance to visit the interiors and to look out, you will realize that the glass looks stunning, amazing, very transparent, with no optical distortions. I also mentioned that we took care of all the glass, also the curtain wall. So detail for the curtain wall, we can see the glass was double glazed, also combination of solar control and high selectivity coatings to get excellent G value and excellent U value and G value in this case. But once again, the client was really pushing to get very low anti-reflection to the inside overall at night when we are looking out. We also took care of the glass at the Sky Garden. Glass is quite simple in this case. The shapes are complicated, but the glass is basically a double 10 heat strengthened glass. Beautiful view from inside out. All these panels, all these compositions that you've seen were produced with an oven that does curved, toughened, or heat strengthened glass, cylindrical, up to 18 meters if we need. So we can do fast production, producing glass slides every 20-30 minutes in big sizes and to high standards. So the oven looks like that. This is a beautiful machine, but has some limitations, logically. So the center bottom part of the oven is fixed to the chassis, to the structure. So we can lift the sides and with some vertical chains and generate cylindrical geometries, basically. Cylindrical geometries to 3.6 meter arc length and 18 meter long panels. Fantastic. But it has some limitations. If we go down and we take a look to the inside, we have a nice area of the building which has a 888 millimeter glass with a mirror coating at the restaurant. In this area, we didn't use that machine that we've seen. We didn't use the tempering. We used the traditional bending. So we manufactured customized bespoke molds, steel molds, laying the glass triple layer over the mold and just slumping the glass little by little over the structure. Process that takes not 20 minutes, but 8 hours. But that was the solution to deliver this high quality 3D bent glass with highly reflective coatings. This is it. This picture shows quite well what I'm talking about. So here we have to be very precise when we manufacture this steel mold and when we are slumping not just one light, but 2 or 3 or 4 glass lights at the same time. So once the glass has touched the oven, the mold, we can start the cooling down, which has to be a long cooling down that we call annealing, so that the glass is strong and stable. Afterwards, we can proceed with lamination. At the ground floor level, we have another example of something very unique. Once again, we have here a portion of the building that was actually done by Sile as the banquet hall and engineered by Ujjal O'Callaghan. In this case, even more complicated. The panels are not just 7 meter tall like at the banquet hall, but 11 meter tall panels. Structural glass. No structure backing the glass, supporting the glass. So this is why the glass was engineered to 7 layers of 15 millimeter, also once again with sentry glass. So even more complicated. But once again, if we take a look to the ground floor, it's amazing. The quality is outstanding. We cannot see almost any distortions, not even in the curved glass. So that's really very complicated to be achieved with automatic ovens that produce glass in those big sizes. Another very interesting part in the building outside is this suffix of the building that goes inside. Highly reflective glass. In this case, that's double 10 heat strengthened glass with, once again, a highly reflective mirror that looks like this. So I'm sure you've seen the building. I'm sure you've seen the site. It's outstanding. And the glass is has been machine bent, has been heat treated. But take a look to the reflection. It's amazing. It's better than any of the flat glass, toughened glass we can see worldwide. So it's a high quality, reflective toughened glass. Even when we look from inside out, the optical quality, it's amazing. And this was done with a new equipment that we had integrated when we got the order for the building. So with the previous oven you've seen, this glass is not feasible. So we had to invest in this equipment that is an outstanding equipment, also with some constraints, but outstanding equipment that allows us to bend in one direction with 7-meter radius, an arc length of 6.5, and in the short sense, 4-meter radius, 3.6 meter. But that's it. So it allows for spherical 3D bend. But once again, the center of this machine is stuck to the bottom, so it cannot go up and down. So we can just bend in one direction, so generate certain geometries. Yeah, it's very interesting, enough to deliver the glass for the Henderson, but not good enough for the feature. So what's next? So we were at that moment already thinking of our friends, architects and engineers that are always raising the bar and thinking of more complicated stuff. Thinking how we can give an answer, how can we support the designers and engineers in the next future projects. So in this case, we decided that we went ahead with what we call the multi-curved tempering. And this was presented already this year in Munich Bau in Germany. So this is the panel that you can see here is the first prototype produced with a bespoke configuration in that oven. But afterwards, we proceeded, making the technology a little bit more sophisticated. So nowadays, we can make things like that. But this was feasible up to today with a traditional bending system, making a mold, as we've seen before, and slamping the glass. But not with machine bending, not with tempering and heat strengthening. So things that complicated now, from today on, are feasible. Things as simple as concave and convex are also feasible in this oven. So we architects and engineers do not have to worry any longer whether the coating or the ceramic frit is in the convex or concave. Forget. You don't have to worry about that any longer. The oven does it all automatically. But also geometries as simple as conical and J shapes that we can see in many of the designs in towers that are just feasible in slamping and nail glass now are also feasible with tempering or heat strengthening. And also horse saddle shapes, so anti-plastic geometries that are so complicated in glass bending. In parallel, we knew we had to design, also engineer software to give quick assessment to designers, so that when architects and engineers are coming to us asking whether or not certain geometry is feasible, we can give an immediate answer saying, yes, this is feasible, this is not, or just recommend some changes. So projects like this, that I'm sure you've seen before, the Philharmonica in Hamburg in Germany, delivered by our group 10 years ago, the glass here is annealed. I mean, there was no way at that time that these double glazed units with 2 coatings and a dark ceramic frit, that was not feasible in tempering. But today, with the new equipment we have, this project would have been feasible in either tempered glass or heat strengthened. Thank you.
Thank you, Joan, for very inspirational and show the latest technology of how to fabricate the glass. So looking forward, there will be an interesting project in Hong Kong to use the latest technology. So I would like to please introduce Yanxi, the director of EOC, to be the moderator for this panel discussion. Thank you. Brilliant, thank you. I'd like to welcome to the stage first Kevin Ng, Senior Deputy General Manager of Henderson Land Development. Kevin is the person in charge for the Henderson. Kaloyan Naravinov, Associate Director for Zaha Hadid, based here in Hong Kong. Kaloyan is the design architect for the facade package, amongst many other packages on the job. Simon Chan, third time on stage, Technical Director of Far East Façades. Nicholas Wachter, Chief Operating Officer of Sealy in Hong Kong. Brilliant. It's a very quick introduction. Impossible to ignore, and the talk of the town, Hong Kong has watched as the world's most expensive plot of land was purchased, its car park demolished, a concrete and steel structure has emerged out of the ground before finally clad in glass to reveal its final form. Hong Kong has seen glass towers before, but none like this. So, I'd like to go to you first, Kevin. I hear there was a hard-fought design competition before the Zaha Hadid design proposal was chosen as the winner. How did the Zaha Hadid design compare in terms of technical challenge for facade? And as a client, how did you choose this path that requires innovation from the design, from the supply chain?
Thank you, Yanchi. We got this piece of land through tender back in the third quarter of 2017. And immediately we held a sort of a design competition. Eventually, we chose Zaha this scheme. And we like the scheme because it is basically a sculpture by itself. So, but at that point, we are well aware of a number of challenges on the face of it. And first, like it is a 3D curved all glass design, and with very complex geometry and also large piece of glass. Secondly, and because it is a sculptural form, we did away the sort of external sunshade. We don't have external sunshade, but unluckily, our site is facing, the principal is facing west. You can imagine the challenges we have. And the third one is that, and I believe that for a high quality facade and also for water tightness, we are bound to have a unified system. So to be honest, actually, our top management asked us one question before we award the design contract, is that whether we can build it. My friend answer at that point in time is actually, boss, I don't know. But give us some time and to figure out how to do it, because we have a strong belief that the saying is where there is a will, there is a way. So we took the opportunity to why don't we just squarely face the problem and figure out what we can do to overcome the challenges. You think that the biggest problem nowadays actually you don't know the existence of problems. Once you know the problem, you know how to dissect it or deconstruct it, then we can overcome it. I mean, I think the results speak the truth. So that was what we have been doing over the years.
Great. I'd like to go to Kaloyan. As the design architect for the facade, what was the main challenge on the project, and has design and fabrication been integrated in a workflow, and how important were digital tools within that process?
Yeah, so basically the main feature of the building is the double curved glass facade, right? Which at the point of the design, we were not aware to have been built anywhere in commercial scale like this, right? So because of this, we had a very early engagement with potential glass fabricators to get back feedback, what is actually buildable and achievable in the industry. And because of this, we had to, this time, we couldn't rely on a typical post-design rationalization and optimization, right? When you have the shape and then you figure out how to make it, just because of the stringent requirements. So we had to incorporate this back into the actual design process very early on. And to achieve this, of course, we had to rely on digital parametric software, because otherwise this would have been a major challenge. Just to give you an example of the complexity we had to face and solve was, for example, we got from the glass fabricators the main constraint, which is the maximum panel size that can be done. For the double curved, also the arc height, which is like the total height of the curvature. But then one major challenge was that because of the tempering, each glass unit could have only one type of curvature, right? So you could not change curvature inside the glass panel. Back to our side, because it's a fairly compact one, that would mean immediately that changing the size or the number of panelization to keep the tangent smooth surface, that would change the GFA and the side coverage area. So it was a very fine-tuning process available through digital tools, basically, right? And then we continued with this 3D development. After the whole tower, basically all facade systems were designed and tested in 3D. And we even went for facade tender with LOD 350 beam model. Extracted cut sheets, regardless that the tender was designed and built, just so that the contractors are really aware what the challenges are. And then this kept on continuing through the construction process, first to check all the changes, if any changes are coming, but also as a base of comparison, because the facade contractors, as a part of the shop drawing, they're submitting LOD 400 beam models.
Okay, thank you. So I just want to go back to you, Kevin. So obviously you have a design, but what measures did you take as a client and a project manager? What did you put in place to manage the delivery of this facade?
So in a nutshell, there are two issues in play. One is the production of 3D curved glass in such a enormous scale and also complexity. The other is actually the installation, because I have a strong belief that unitized system is the only way out. So that's why we go for two things. I think this is the first in the industry, is that we aim for a IMU, we call it installation mock-up, and to make sure that we can really do it to answer the top management's question. So I took the liberty to hire two capable contractors, Far East Façade and also Silly, as a paid service to do some pre-construction mock-up, we call it IMU. And we particularly chose two areas. One is the most common 3D area, doing a 4-panel 3D curve facade by Far East Façade. And another even more challenging part by Silly is actually a 6-panel tight curve and complex geometry area to make sure that it is really buildable. Okay. Eventually, we get past, and thanks to the hard work by both contractor and their good efforts paid off, and eventually become our contractor. The second one we did is actually we erected a really gigantic glass visual mock-up in our vacant construction site in Kowloon, because we believe that glass technology is something that we need to explore. So we have that sort of job case, full size, double curve, 4-ply, multi-coated glass configuration to make sure that we are fully aware of the technical challenges in play. So that is really, really useful, because we found that there are lots of technical challenges, like the control of tolerances, like the control of string pattern, and also optical deformation. And because our glass configuration come with 4 coating, and also we have concave and convex area, you never know. You never know you will be successful unless and until you have done a great job by the job case scenario. So and also because at that point, back in 2019, most of the glass fabricators use physical mode to do that. And you can imagine, and we have to heat treat all glass panel to attain the strength we need. And like Joanne said, we have to push the panel to a oven or cold furnace up to 660 degrees and do a quenching process. You can imagine lots of technical challenges will come. So I think eventually we insisted that we must go for a digital twin, digital furnace, digital mold, to make sure that we can get that sort of ultimate result. Because we have more than 4,000 unitized panel, but among them, more than 1,000 types. So we can imagine we cannot really rely on physical mold because each panel comes with 4 plies. Okay, so I think SEDACs have done a really good job because you can imagine the outboard of the outer pane and with the second layer of the outer pane only differ at each and every point by 12 mm because one panel is 10 mm and the SGP laminate is 2 mm. So it is really difficult and it's really amazing.
Okay, fantastic. So Simon, so you were, for Far East was one of the contractors invited to do the installation mock-ups, as Kevin has just mentioned. How did you approach that challenge of proving that fully unitized curtain wall system would work? And in general, what should early engagement from a facade contractor on a complex project like this, what should it look like?
I think there may be 1 or 2 projects using the double curve unitized curtain wall, maybe in Middle East. I think we did not have any reference. We did not knowing how the performance of the unitized curtain wall in Asia. Something like in Hong Kong is higher wind pressure and the higher wind force. So I think we have a lesson learning from the MU. During the installation mock-up, we learned that how we can twist the mullion. So and at the beginning, we did not have any machine that can be bend the mullion in 2 directions with the twisting. So at that time, we think about whether we have a digital machine to make it. And after that, we also finding that we cannot using a traditional method to checking the tolerance of the glass. And we using the 3D scanning. And during the mock-up, we take a lot of time, even 1 day to calibrate one piece of glass. I think if we using the same principle, and this is not work for 2,000 panel. And another thing is very important. For this projects, almost 60% of the contract periods at the COVID pandemics. So I think if we did not have the installation mock-up, we will not well prepared for the tender or for the job case. So I think this is a very good lesson learning from the client.
Yeah, fantastic. Thank you. To Nicholas. So Celia is the facade contractor for the top of the building and the bottom of the building as well. As Kevin has mentioned a 3D curved glass mock-up as a technical verification of the double curved glass being possible. So what went into perfecting the production of that double curved glass, and what are the benefits of Celia being a facade contractor and also having a associated company in SEDAC being a glass fabricator?
Okay, Janshi, thank you. I would say the question in terms of the double curved glass is more related to our sister company SEDAC, but I try to give you a proper answer. The geometry of the double curved units is quite complex, as we have heard before already from Joanne and Kevin and Simon Caloin. But it's not only about the geometry of the glass units, also the very challenging coating buildup of the glass units did really challenge us. You need to know that the coating buildup or the coatings of the single glass layers do affect the heat absorption behavior during the bending process, and each single layer behaves differently during the bending process, and that was quite a big challenge. And we had to do a very comprehensive bending study prior to the serial fabrication to figure out how to curve the bendings, how to set the temperature, and how to apply the cool down rates to get finally the heat strength that glass with a proper pre-stressing level. And that was quite challenging also. In terms of a collaboration of both companies, Ziele as a facade manufacturer and sedak as a high quality glass supplier, from my point of view, the biggest advantage is all from a single source average. The client gets from us the design, the engineering, performance testing, the fabrication, assembly and installation, all out from one hand. And that ensures, let's say, a smooth progress in terms of the project. And it's also important to note that this configuration enables us to react on design changes very smoothly. We have a basis for after sales services like maintenance services and many more. I guess the all from a single source approach is the biggest advantage. Yeah.
Okay, thank you. Just staying with you, Nicholas. Ziele was involved with facade contractor for the banquet hall at the top, or it's called Cloud 39 now. The ground floor lobby and also the belly facade towards the bottom of the project. So sort of the more special feature, non-unitized systems. Were there any sort of special performance requirements on the project, on those packages?
Yes, for sure. We had to carry out quite a comprehensive performance testing of different facade areas. But there was really one special performance requirement in terms of typhoons. The typhoons in Hong Kong bring very high wind loads onto the facade, but not only the very high wind loads and pulsating loads are challenging the facade. Also, flying objects speeded up from the ground or falling down from higher heights had to be considered in terms of the structural performance testing, and therefore it was decided to conduct a small airborne missile test to test the facade, or to let's say elaborate the resistance of the facade in terms of impacts. And I have been told in case or in terms of the Henderson project, it was the very first time such a typhoon test was carried out in Hong Kong.
Right. I remember speaking to the Hong Kong curtain wall testing guy, and he said, I remember doing the test, like firing pellets at this piece of glass, and I've never done that before. So I'd love to have seen that. Okay, just want to go to Simon. So obviously you mentioned that, we've had COVID, and obviously you have this challenge of delivering a package for a very complex project. So what were the logistical challenges during COVID with the sort of production and assembly across borders, and the improvements that you made in-house to your sort of capability? How do you see those being carried forward into future projects?
I think we mentioned that there's a COVID pandemic. I think in Hong Kong, most of the construction industry are facing the same problem. because of the shutdown of the Chinese border and even the shortage of power in some industry area in China, like Dongguan. And, for this project, and we ordered the glass from Germany. I remember one incident happened during that time. A cargo vessel and grounded on the Suez Canal, and it blocked and disrupting the transportation from Europe to Asia. So at that time, I think every day we checking the shipment schedule, and sometimes we need to reprioritize our shipment schedule, and some of the glass may be air freight. But I think one of the important, we need to have a transparent communication with client, main contractor, collaboration with the team, so that we can work for better performance for this one.
Thank you, Simon. So to Kaloyan, what has this project demanded of you as a design architect?
Well, it was challenging for sure, particularly with the industry is getting more and more fragmented, right? And in particular with the type of architecture that our office does, which is a little bit more holistic, where you cannot really differentiate between different domains like facade and interior. There's always some interconnectedness, right? Which we are used to it. I mean, it's a little bit of an extra effort from our side. That said, though, we were very lucky with this project to have a very an extraordinary team of consultants and which huge amount of expertise, specialist expert. And then on our side, though, as a design architect, this required a little bit more engagement, right? Because just because of the complexity of the design, we have to get engaged also in some of the structure coordination, MEP coordination, all the detailing between the different trades, right? Because in our design, everything is interconnected. And also, it was a lengthy process. So, as I said from the beginning, we get feedback from construction or fabrication, and then tweak and refine the design as well. Which, for example, just to keep everything uniform, for example, all the geometries and the presentation for this project came from us, from the design architect, right? We didn't sublet this down to different contractors or consultants to do, right? And this was mostly done in 3D environment, BIM environment, but on our side, we had to do it in a role as an architect, not as a BIM specialist, for example, right? Because what we find out is that this process, a lot of these decisions are design decisions, right? So they are design responsible decisions, which we had to gauge.
And I know from the sort of the packages that I've worked with you that it's your role as design architect has required you to be across everything, and actually it's quite rare for an architect to be capable across all that, from design, delivery, documentation, 3D, materials, everything. So it's Chloe's very good. And just want to go back to you, Kevin, with your client and developer and project manager hat on. What lessons have you learned from this project, and where do you see the industry going in the future?
I think a number of things. I agree with what Andreas of HS&A said just now, and meeting the standard is not good enough, right? So like what Nicholas said just now, we have the first missile test for the glass facade, And because we have super typhoons every now and then, and I think back in 2018, September, we have the super typhoon Mangkhut, right? And I think it's a wake-up call to everyone. In the past, everyone just talking about global warming. But I would say that global crisis is the more important point, because you have tornado even in Hong Kong, Guangzhou, you have other adversity. So we have to brace ourselves up, and we have to be more forward-looking. So our strategy being implemented in the Henderson is that we try to buy in the wisdom of contractors, especially the specialist contractor. And to be honest, for this project, the first two contractors we team up with is not the main contractor, it's actually the facade contractor, because they are the key to success, I would say that. Because we are not buying their skill work, okay, but we are buying their knowledge to form as a design team. We take the contractor as a design consultant, okay, to have buildability and constructability input. So I think this is successful. And another thing I have always had in mind is that in the digital era now, customers' expectation is getting higher and higher, and meeting the standard is not good enough, and we have to cut short the product life cycle, somewhat like the consumer product, your cell phone. Okay, our cycle is too long, way too long, 5 years, but your cell phone is just 3 months. All right, so we have to be innovate all the time. But don't make it wrong. We are not trying to try to innovate and do innovation. But that goes back to the saying by Albert Einstein: necessity is the mother of all invention or innovation, right? So we have to think what the society needs, what the future users need. We have to keep ourselves innovate at all times to meet the necessity, be it aware or unaware.
Okay, thank you, Kevin. So, can we take questions? We've got plenty of time. Fantastic. So if you've got a question for the panel, please raise your hand up. I'm going to ask one last question for the panel, but please, if you've got a question, could you put your hand up and we'll pass a mic on. Okay, so I'll just continue for now. So a bit more of a sort of personal question to any of you. You're free to answer. I know I've been involved in one project that has consumed me for several years, virtually full time, right? And at the end of it, I didn't really know what to do with myself. It was, you keep going for a prolonged period of time. You're looking at the same issues every day. You know the project inside out. And it really consumes you. And then suddenly it kind of ends. And I felt I didn't know what to do next. I didn't know whether I needed to keep going on to a next thing, or I just needed to do something a bit more straightforward, a bit simpler. Now that we're coming to an end on this one, what have you got any feelings on how, what do you want to do next? Do you need to do another big one, another challenge, or just take a bit of time and do something a bit more straightforward? Kaloyan?
Well, it's kind of, for me, it's not the first project, right? I mean, it's like delivered already 4 projects for Zaha Hadid, so you kind of get used to it. It's kind of a life cycle, because every project have different stages, right? It's stuff like, and for us as a designers, actually, the end part is a little bit earlier when the actual design is already finished. So we are kind of overlooking that everything comes together right. Yeah, but you don't know. I mean, it's like, sure, you need a break after such a job, for sure.
Right. Anyone else? Strong feelings? Simon's always jumping from one to the next. No. And I think Kevin probably has to keep whatever he's going to do next to himself. And
I think teamwork is really important because I always think that there is no Superman who can resolve all the problem, really, because the expectation is getting higher and higher. We get used to do something new, okay? And we have to be brave enough to embrace the problem. Then there is no such off-the-shelf solution. So that's why our project management strategy is to team up with capable person first, okay? And we take on a round table sort of arrangement, collaboration, so that everyone can speak out their insight from their own perspective. Then we can squarely deal with the problem and to get something new, okay, in a way.
Yeah, great. Do we have a question?
Hi. Hey. Hi. Thank you for the presentation. I have a question about specialty. You know, back in the days, architects does everything, right? We're the master builder. But as like, you know, we go into our current trends, it's that we get more specialized. But because of all the specialization, we're able to do something unimaginable almost, 50 years ago. But, do you think that we're getting split into more and more specialty? And is that taking away from, architect and designers' ability to do more things? Are we relying on a lot of consultants? I mean, we know we love collaboration, but at some point, it's almost like we're losing control as well. So, how do you balance that in this project with your long list of consultants?
Who would like to take that?
Asking me? To be honest, we don't have such a long list of consultants, but when we come across a problem, we don't just sit there. We have to take action. Then we have that sort of a big team of consultants growing, and sometimes we have second opinion. We go for second opinion, right? That's why we have 2 IMU instead of 1, right? And different perspective have different emphasis. I would say that, and so. I think when we really care about something, you have to take it serious, and you need to listen to more views from different perspectives. So the long list of consultants is not the intent. The original intention is the outcome in order to address what we need. For example, we have security consultant. Not just physical security consultant, we have cyber security consultant. This is not the idea that we have originally, right?
Yeah, I remember when I asked for the consultant and contractor list from your team, and I sent it through, and you would have seen it on the screen. And it's quite a long list for a single building, I would say. I've seen longer on sort of bigger, more complex, on let's say not more complex, but more typology diverse projects, let's say. But I know in your list you have little notes saying US engineer or local consultant or German contractor. It's quite interesting you note where they're from. Great. Does anyone else would like to respond to that question? Is there another question we can have? Sammy.
Yeah, thank you for the great project showcase. And I'm also been honored to participate through my DAO experience. It's a beautiful, safe, weatherproofing and structural glazing. And just a question for Zach. Can we consider our next event on the rooftop of Henderson. And then that will be a real showcase. They can experience, in person. Thank you.
Well done, Sammy. Well played. Okay, we do have more questions. Fantastic. Let's keep going.
Kevin, I knew a little bit about the project. Can you share with all of us about the special things that you did? One is how to ensure the glass is perfect before it's delivered from Europe. Okay. Second, what did you instruct in order to avoid structural silicone on site for glass replacement? And third, the last couple of left out panels, what did you require for the installation or closing up the facade? Thank you.
Long question, I'll say.
No, it's quick answers.
So,
know all the answers.
Let me go back to what I listened to Andreas of HS&A said. Okay, so our expectation is getting higher and higher. Like you buy a car, okay, you cannot tolerate any scratches. Am I right? So I think you asked the right question. In this project in Henderson, we have specific technical and performance specification for the facade. And one thing I didn't mention is that you prompted me to say is that we have a facade resilience concept. Okay, it means that we try to do lean construction. We don't overdo anything. If we even don't have any spare glass, okay, there is no need to do that. But we have stringent requirement in the acceptance of glass. So actually, we use heat-strengthened glass, not fully tempered, because we want to maintain the facade resilience, and we don't want to have scary pattern when it is broken, because we cannot control flying object, like what Nicholas said, but we can control how it look like when it is broken. So that's why we specifically stated that we must check each and every glass pane in the production factory that it must meet the heat-strengthened glass standard. In other words, it must be tested, checked to be within 24 to 52 MPa, lower or higher will be rejected. This is one thing. The second thing is that we check each and every panel in terms of tolerance. That is plus 3 mm, minus 7 mm for each and every panel. If it is out of tolerance, it is rejected. And also, we checked each and every panel in terms of optical deformation. This is not something that incorporated in standard facade glazing check. Optical deformation, strain pattern, etc. So we don't want to waste time for everybody. You deliver a panel, glass panel from Switzerland to Germany or to mainland China is a waste of energy, right? You don't need to do it if we reject right away in the factory. So I believe I have answered the first question, right? I forgot the two other questions. What were they?
Eric Ray.
Oh, I see. All right. So that goes back to the second question. We don't have any structural sealant work, even for the replacement of glass. You watched the video that we tried replacing one piece of unitized glazing panel, just 7 hours, without any structural sealant, because each piece of double laminated IGU come with a carrier frame, okay? Each carrier frame come with 60 holes. That 60 holes will be matching with the unitized curtain wall mounting and transom, another 60 holes. You can imagine that the new panel come with a new carrier frame with 60 holes, will be exactly matching with the existing 60 hole. That is very difficult, just like IKEA furniture. Then I think this, we thanks to the digitization by Hadid, we have 3D models. So, but contractors' input is also important. You have to build exactly to that curvature with that precision. Otherwise, you cannot replace a new piece of glass
simply by mechanical means without any structural sealant. So that's why, because of a facade resilient concept, we don't have any spare glass. I think this is a sustainable means because you don't need to waste resources to doing spare parts, spare glass, and there's no need because we can buy time and do it, say, 2 or 3 months later, or you don't need to have a timber planking in order to block off a smashed facade, right? Have I answered all your question? The last one, what was it?
Kevin, is the last 2 panels.
Oh, last one. Okay.
Facade.
Okay. I hate that because usually the last panel we call it tap jump. So it's just like putting a needle in it because usually the bad practice of facade construction is that the last panel is that you have to shift the panel and then push one inside. I hate that because by so doing, you will have the gaskets dislocated. When you move back the panel, it's all dislocated. We didn't allow that. So for the last panel, instead of doing something like that, we do the closed door panel first. By so doing, you don't have the gasket being dislocated and keep the water tightness intact. Have I answered your question?
Perfect. Great. Okay, I think we can have one more question before lunchtime.
Thank you. I'm coming here with a structural engineering background, so some of the the questions are sort of beyond what I'm normally doing, but I've seen a lot of amazing technical solutions. My question is perhaps for Nicholas and Simon, but Kevin, I think you started off your presentation by saying some of the challenges that you had to overcome initially had to do with distortion on the glass. Simon and Nicholas, what was the technical solution behind that, especially for these very thick units? And what do we think, how far it can be pushed with the current technology? Thank you.
Great. Nick, do you want to talk about the clarity of some of these larger build-ups?
Yeah, for sure. I guess the biggest challenge, as I mentioned before, is to evaluate the bendability or to check the bendability of the single glass coatings. Take a look to the belly glazing, to the IGU glazing from the 3rd to the 5th floor. It's a 4-plies IGU, and every glass ply has a different coating. 3 of the coatings are compressed while the bending curve, and 1 coating is stretched. And the biggest challenge was indeed to find the configuration, the bending configuration, to stretch 1 coating. And the feasibility or the doability was checked via a bending study and via mock-ups. And to give you a clear answer how far you can push these boundaries, from my point of view, it's not possible. It's a job case. It's a job case a question. Yeah, you need to check.
I just want to add on about laminate. Like, obviously, the reason why we have thick glass build-ups is because it's spanning. We're using glass to span, in this case, vertically. In the banquet hall, it's 7.5 meters, which we were involved in as EOC. Lobby was 7.15s for 11 meters. I think. The requirement from the client and the designer was frameless, so we didn't have mullions, we didn't have fins, so long span, top to bottom, how thick is the glass. Now, one of the issues we have in Hong Kong is buildings department and the composite action. So when you go to BD, you basically assume a composite action maximum 70%. Usually we take a more conservative estimate, but then it has to be proven using a 4-point bend test on a sample, which is, I think, just short of a meter. And the issue with that is that for thick build-ups, it's the wrong test. So you basically get results that don't justify composite action. So that there is a bit of an issue, I think. It's quite a really big issue that needs a way forwards. So I think that's probably going to be our last question. I'm going to be good and end on time. So I just want to thank Simon, Kevin, Kaloyan, and Nicholas. Okay. Could you put your hands together and thank our panel?
Thank you, everyone, for this engaging discussion and for these iconic projects in Hong Kong. Thank you, everyone. I think we will have a lunch break, and we'll be back in 40 minutes. Please enjoy. So hope everyone have a great lunch, and we would like to invite our speaker Ujjal, associate principal from SOM. The topic is integrated facade design, balancing performance, craftsmanship, and architectural expression.
Good afternoon, everyone. I am Ujjal Roy, Associate Design Principal in SOM's Hong Kong studio. Hong Kong has been my home for the past 15 years, and I'm very proud and privileged to present to all of you attending the conference our HK Hong Kong project, the Tung Chung Business Hub. Located in the northwestern coast of Hong Kong, on Hong Kong's Lantau Island, next to the airport, Tung Chung Business Hub is envisioned as a next-generation hub for business and commerce. Composed of 2 towers, above a multifaceted pixelated podium where every aspect of the design is centered around creating memorable experiences, reinforcing connections with nature, as well as optimizing the architecture for efficiency and performance. So I want to start with the question, what makes Tung Chung Business Hub distinctive? So first of all, it's about the unique program mix that we had to blend into the site. It's a retail mall, an office tower, and a data center. A data center in particular, which is a building basically designed for machines, not human. Paradoxically, on the other hand, we had to blend it with an office tower and retail, which is more associated with people, users, using those buildings. So how do we bring this world together was one of the biggest challenges we had to face. And layered on top of that is this idea of place, especially for Tung Chung, this new residential master plan that the government is planning for. We have to make sure that this project gives Tung Chung an identity that it can latch onto. And it was about the people using the project, be it the office workers, be it the people visiting the retail mall, or be it the neighborhood, people coming here, gathering, engaging, and of course, prospering together. And last but not the least is the performance of the building, be it the structural system, be it the planning efficiencies, be it the HVAC system. It was all about efficient performance of these elements in the design, but with the target of achieving the highest sustainability possible in the project. We took a step back and asked ourselves, what is inspiring this project? It was a lot to do with the context. So Lantau, as some of you might know, it's a very lush island, a lot of green mountains, and a very charming fishing village called Tayo Fishing Village, a floating fishing village with its quintessential boxes floating on stills. Secondly, it was about Tung Chung, the community there, a growing community, of which I can say proudly that ever since I've come to Hong Kong, I've been part of that community. And for me, the project held really hit close to home. And our target was to bring these qualities and bring it into our project. And how can we represent that? So how do we achieve these design objectives? So firstly is responding to a site, quite a unique site. If you look at this diagram, you'll see that almost 90% of our neighbor is residential project. And how do you address that? How do you put this unique program mix to engage with this neighborhood that you've created? Second and thirdly is this the linear park adjacent to our site towards the east, and the Tung Chung Mountains, which we knew that we'll have always in our project. So how can we maximize those views? And lastly is the currently under construction Tung Chung East MTR station. How can we connect all these moving parts into a project? So that's where we started to conceptualize the massing. First point was it's about connectivity and presence of the project, especially at the street level where You want to capitalize on the footfall of the people going to their residences or going to work using the MTR station. And how can the retail have that presence in the lower portion? Secondly, is this creating this symbiotic relationship between the office tower and the retail mall? How can one help each other, be it sharing of programs, be it sharing of footfalls? And lastly is maximizing the site potentials, be it making sure all the office tenants get the amazing mountain views towards the south side, or making sure the retail has presence on the main portions of our project, in the linear park and the street front. And lastly, making sure the data center, which is a key component of our project, is not hindering any of those other more public programs. So it's a simple diagram. You can see we align our office tower core with the data center massing. All that gave us this opportunity and gave us this system where we interwove into the neighborhood at multiple levels. So the idea of making sure the project itself is accessible from pedestrians, be it especially from the street side, engaging people, bringing in people from the linear park side towards the east, and lastly but not least, the future planned MTR bridge. That was also a key factor in how we conceived the design. How can that bridge link to our project seamlessly? So with the first image I want to show you is what we're calling the retail village. In this image, you see how we've played with the pixelation of the boxes, which creates very interesting spaces like terraces, alfresco dining possibilities for the F&B associated with that, or these gaps, these interstitial spaces between the boxes that you see, bringing in more light nature into the retail mall inside. In this image, what you'll notice is the MTR bridge is not there. So this is the initial stages of the project when the bridge will happen only when the project across the site gets built. So the idea of how do you engage that linear park, how do we make people come up seamlessly into the project? So multiple layer of infiltration into the main retail floor at L1 was critical for us, and making it as convenient as possible. So starting from the linear park arrival, very easy. You have this presence, you can see from eye level of the pixelated, very exciting boxes there, and the escalator taking you up very, very easily. But it was also about the neighborhood facing facade. How do you make sure that there's a very recognizable identity of the retail element there, where you see the portal framing our main entry into the mall, or the smaller portal towards the right-hand side of the image, which is basically our curb cut and the vehicle entry into the project. If you notice, also in the neighborhood facing side, we wanted to soften the presence of the data center as much as possible. So be it integration of green wall, where at the street level, or be it integration of a kinetic art facade wall in the data center, which will be facing the neighborhood, was quite key for us. But when the MTR bridge gets built, it becomes like this key moment of arrival for most of the people of the neighborhood, and also people visiting this retail mall. Integrating it with the design became quite key. Also, part of it was also making sure this is part of that 24-hour public path engaging with the retail mall. As you can see already, how architecture and structure is creating this dynamic gateway moment with the bracing, emphasizing the main retail atrium and the arrival to the project. For us, the podium, especially with the retail, was all about the community and all about how the community can come, engage and interact with each other. In this presentation, I'll focus on two of these entities with in relationship to the facade. What we're calling it the retail village, which is essentially the retail boxes that you see here, and a bamboo grove, a specialized area inside the retail mall. For us as designers, we wanted to balance this idea of commerce, art, and community helping each other out, woven together for mutual success. So these interstitial spaces and these opportunities, this playful pixelations give us was terraces, give us openings into the retail mall, and amazing views of the linear park landscaping, lush landscaping that we have here, or even the mountain views you can enjoy from having a drink in the evening after work facing the linear park. So all that informed the design sensibilities here. Taking that idea of immersion into nature even further, we consciously put a very low carbon palette on the facade, be it the glazed terracotta tiles with texturing on it, the green vertical wall, natural granite for the flooring, But accompanying that is also this warm bronze texture for the mullions and the stick system that we thought was quite complementary to the overall composition. The terracotta facade, very, very important for us. And the first reason being it's a natural material. It's a very low carbon material. Secondly, there is this notion of ceramics. There's this notion of hand-built natural quality that we wanted to inculcate into this retail boxes, making it a bit more closer to home. We had our own challenges with the substructure, the Hong Kong regulations of keeping all these elements within the allowable facade zone, and gave us opportunities to explore how we can break down these terracotta facade into pieces to get it past the government without any GFA penalties. Secondly, in our proposal, we did highlight terracotta itself is already a low carbon material, but what increases the embodied carbon of a facade system? It's also the substructure. So in our proposal, we did focus a lot on making sure that all the substructure has as high as possible carbon content available. So just by 50% of substructure being using recycled aluminum, we drop a 30% of carbon content for the facade system. We obviously looked at other panelization options as well, but as it is very evident from the slide that you see on screen here, in all that, terracotta gave us the balance of very low embodied carbon and less material usage, less a metric ton of carbon per facade system, where it's very evident, be it using, if we had used an aluminum panel, how much trees of embodied carbon that we're saving, almost 10 times compared to what it would have been if for aluminum. So that we thought was quite important for the project to portray. Taking that facade language into the vision glass area for the retail itself, again, the framing, in this case, we've used terracotta tiling, keeping it very clean, and the infill panels where we have the vision glass and the mullion system, nice, clean, not an issue, very flexible, where we can integrate doors at where we have terraces, accessing the terrace locations, where imagine if it's a restaurant, you can open up completely on a good day, and especially in winters where the dining experience could be both indoors and outdoors. Seamlessly, we also integrated, for flexibility reasons, this decorative louvers that you see on screen right below the spandrel. And what it gave was each of these boxes had the flexibility to transform from a normal retail, say like a clothes shop, to an F&B typology at will, because we can use those panels, which has potential NEP panels behind it for, say, kitchen exhaust or fresh air requirement for kitchen. So that flexibility we really wanted to build into the project. So come tomorrow, if there's more F&B requirements, shop can easily transform into that. Now going to the south side, which is basically where the building will be seen mostly from the expressway, the airport express, the MTR side. For us, it was about this transparency and that material continuity from what we had achieved on the east side towards the neighborhood side. And as you can see, we used the movement of the people in the building to compose our pixelation on the south side, be it the lift shafts taking you from your ground floor drop off to the sky lobby at level 5, or the escalator bringing you from Linear Park to your atrium, what we call as mountain room, or the express escalator that you see going from your main retail floor to L4 and then taking you directly to your office lobby floor. So all that helped informed our design, especially for the express escalator, what we're calling the bamboo grove. For us, it was very key that as you go to your office or as you leave your office, you are always part of that view, always part of that mountain view, and always part of nature as a mean of transition from work to home and from home to work. So we use that opportunity to create very as light as possible facade system here, where we integrated a detail where the glass panels are divided in 5-meter pieces, where supported by the steel mullion. You'll also notice is that there are these latches for the gravity load for the upper glass system, which was integrated in the joint line, so that we avoid any extreme horizontal transverbs in the project. We thought that was quite smart, and it helped in keeping that facade clean, especially from the outside in and also from inside out. As you can see in this section already, you see how the transition from level 1, which is the bottom portion, to level 4, which will be the express escalator for office users or even for retail users, where at level 4 we had proposed cinema floor, so that this escalator was not just for offices but also works for the retail planning itself. You'll start seeing hints in this image where the terracotta cladding that we've developed for the outside facade surface is also starting to inform some of the design moves in the inside. Terracotta, but also the green wall in this particular image. So this image the escalator and the lifts leading up you to what is the office sky lobby, where on the right-hand side of the image is the lift box coming up, and on the left-hand side of the image are the lifts taking you to the upper floors of the offices. So you start seeing how we've integrated or extended the terracotta design from the outside into the inside. Even the soffit and the flooring is the materials which are happening outside blending into the inside quite seamlessly, and we think that gives this office floor the opportunity. What did I do? Sorry, I think I skipped to the last slide. Apologies for that. Yeah. So all that move was to celebrate the unhindered mountain views that we have and making sure that experience at that L5 lobby is immersed in nature. You would notice here that there is an outdoor terrace, which is an extension of the office lobby, but that was not the limit of our landscape design. It's the views beyond that is also becomes part of that wholesome experience. All these spaces that you saw in the project, be it from the retail boxes to the atrium, what we call the mountain room, the bamboo grove, and the office lobby, we created a language which was a continuity of the design expression for the facade typology, be it in terms of the detailing, be it in terms of the material quality, the material color itself, and the texture itself, giving you a more holistic and a very unified expression within the project. That design continuity just didn't stop at the facade level, but for us, it was also about the spaces inside the mall. So be it the first image, which is the main retail atrium of the project, where we still have this aspect of enjoying mountain views towards the left, or making sure that, there is this idea of a living room for the neighborhood where we incorporated seating on the edges, overlooking the L1 floor, potentially having performance there and people enjoying a performance for maybe a piano player, and also integrating a translucent BIPV LED screen, which can help, which doesn't block the mountain view too much, but also can add dynamism to the space. And as you will see the vignettes from the other images, the introduction of nature, the introduction of natural materials such as bamboo, cane ceiling typology, terrazzo flooring, all that adds to our idea of immersing people in that experience of nature and natural materials in this space. That was the retail, but now I'll talk a little bit about the office tower. The office tower for us was all about efficiency, performance. How can this office perform as efficiently as possible? And what we came up is what conceptually we're calling it the solar sail. The office tower itself was a very simple massing. We wanted to maximize the view of the mountain, so we opted for a long office block with the core off-centered to the side, which is in complete alignment to the data center, making sure that the data center doesn't mitigate any views. And of course, integrating balconies and terraces where we can, together with the bracing system, to have additional facilities that the tenants can enjoy. And the three key features for the office is the views for all tenants. The mountain views is something which is very high, which benefit for the project. So we wanted to maximize that as much as possible, hence the long tower footprint. The views itself is facing south. So obviously there's a balance we had to play between shading and making sure we have enough translucency there so the views are not mitigated by any facade system. And lastly, it was about structural innovation. The biggest portion of the project is the office tower, and how can we innovate in the structural design of that system. Starting with the planning, it's very evident from the tower plan that it's a very long linear planning system with balconies integrated at the east and west ends. And then it's the flexibility of almost all the office, or I would say probably 95% of the office floor plate get unhindered views of the mountain. That we thought was quite a good achievement for the project. Of course, integrating similar to in the podium where we integrated nature at every possibility, be it outdoor terraces or indoors, we integrated that also in the office for the users, be it at the sky lobby or at the sky garden level, what we're calling it the orchidatum, and of course, and lastly the roof garden. Starting with the orchidatum, it's a sky garden typology where you can imagine people from the office coming out, maybe having lunch, having a yoga session, or have communal presentation there. So the whole office can, different tenants can engage each other here. Additionally, it's also a space where potentially you can informally work here. Maybe take a Zoom call while sitting next to a very rare Hong Kong orchid. For us, the landscape here was very key. So we tried to promote something which is very specific to Hong Kong. So we celebrated Hong Kong's orchid plantation and integrated into the design. And, it can be part of promoting it, but also for educational purposes. You can imagine the neighborhood kids coming here to learn about Hong Kong's orchid. All this with the view that this space is naturally ventilated as well. Again, the idea of integrating nature goes to the roof as well. Of course, the roof is a bit more harsher condition. It's not shaded. So we opted for a bit more drier landscape typology here, still open to the tenants to enjoy on a nice day. You would notice the roof itself has been integrated with PV panels, the BME system, all of them acting together with as one entity. Coming to the office facade itself, we went through a multiple layered exercise of balancing how can we balance shading, power generation, and costs, aligning all this world together with culminating in a design which is a two-fin system, two shading fins, which not only shades the office floor plate, but also generates power for the users. So our estimation was annually it can produce 160,000 kilowatt hour with the amount of PV panels, or rather BIPV panels integrated in the fins. The fins itself, again, going back to the idea of efficiency, we kept it as minimal as possible. Minimal structure required, of course, facing all the typhoons and wind loading necessary. What can be the minimum that we can build so that these panels can pay for themselves in the long run? Secondly is the integration of operable panels as required by Hong Kong regulations within these two fins. So it's nicely tucked away outside of your eye zone. Thirdly, you'll start noticing some of the profile of the mullions itself. It's tapered. And the reason is we wanted to celebrate the views and making sure that, tapering it towards the user side, minimizing the impact it will have on the views. That was something we really worked hard together with the consultants to achieve. Again, maximizing the glass area, 3 by 2.4 meter high, this one helping us celebrate the view of the mountain even more. So I've introduced to you the solar panels on the facade and the solar panels on the roof. Both of them combined together helped us offset 6.5% of the power usage of the office tower. That equates to 8,300 trees, 5 meter highs, which again, it's a very, very happy achievement for us that we can claim. The last element for the office tower is the structural system, what we call the breathing brace. Basically, together with the shear wall and the bracing system that we've created, it takes all the lateral loading on the building. Associated with that, the simple columns and slab and beam construction, which takes the gravity load, gives us that opportunity to create this structural system. And the question comes, why are we doing that? Very simple. If you do a conventional solution for this long typology of building, you would either end up with an outrigger or you'd end up with a very, very heavy core system to take all those lateral loadings. By moving away from that and using the bracing, it helps us excavate the core even more, especially remembering the fact that this core directly goes to the very high valuable GFA, valuable retail floors at the podium. That we thought was quite innovative in this sense. And in the structure itself, it's a breathing structure. It's a moving structure, be it from the gravity loads, columns shrinking, or be it from lateral loading. The brace itself moves at the node. It takes all those loading and dissipates it within the structure itself and also into the movement of the node. All that was parametrically scripted. The location of the nodes, the size of the nodes, the how the angles meet, and how can we construct it efficiently and minimizing material. All that building onto also the modeling aspect and also the visual aspect. How does it look in the elevation? Especially considering the section was quite dynamic as the design was progressing. That was really helpful in having a very quick way to analyze and give back to the design consolidated this one. All these moves that we did gave us 4 advantages. One is a very structurally light core. Secondly, helped us reduce material by 5%. Obviously, that equates to a lighter building, which equates to less foundation load and potentially saving up to 10% of carbon. This builds in SOM's legacy in steel bracing design, right from the John Hancock Center to the recently completed Fulton Market in Chicago to now the Tung Chung Business Hub. It's an evolution. It's a version 4 of a steel bracing system built by results or years of research and implementation. We're quite really proud of this one. Last element of the project is the data center. For us, it was about feature residency, a vertical and adaptable data center with 3 key components. Firstly, very evident from the image, structure as facade. You'll see in a bit why that becomes quite interesting and key in this project. Secondly is eliminating any and all unnecessary cladding, reducing the cladding, reducing embodied carbon as much as possible. And that is helped by structure being as facade, one thing. Thirdly is an adaptable infill module. So between this framing system, we can have a plug and play condition. Data center design, I'm sure a lot of you are aware, it is basically server rooms packed with all the services, MEP requirements to serve those server rooms. In our case, we had 4 stacks of server rooms associated with that, its own MEP floor. And at the top and the bottom of the tower, it's the larger MEP requirements, be it transformers, be it backup generators and cooling towers in design in this section. And we found a way to efficiently have a grid, a facade system, which also is the structural system for the data center. Again, remember, data center is a very heavily loaded building. What it does gave us is almost 50% of the facade now is not required to be cladded. The columns itself are the facade elements. So that's 50% of the facade that we're able to reduce by a structural system. Why we say this is important is because having a structural facade system also gave us another opportunity, another flexibility, thinking loud about future resilience. Today, data center is in high demand, but maybe 10 years down the line, maybe it might become obsolete, and you don't want to hold on to an element which cannot be readapted. Data center is a very specific type of building as well. So what we integrated into our design philosophy and the design of the data center was how this data center in the future potentially can transform into a retail, into an office, into a residential, or even a hotel, or maybe all the 3 above. The planning has that flexibility, but also the facade, if you remember, that plug and play system gives us the opportunity to remove any facade system we have built in right now and replace it with possibly an office typology or even an apartment typology in the future, giving that flexibility. So that infill facade system currently for the data center is a very cost-effective metal system, which also integrates the louver requirements of the project. Again, remember, it's a very machine-intensive building, a lot of louvers in the project, but it gives us the opportunity to ingrain art installation and window wall retrofitting wherever it's required. You're building in that flexibility for the project for times to come. Here you see a vignette of how that integration of art, maybe a kinetic facade that can easily happen within that facade system, which adds, and this is obviously facing the neighborhood side, so even more the reason to do so. Lastly, the project itself is not a one-man job. It's a team effort, be it aligning with the client's vision, be it taking on board expert advice from all consultants, and achieving and very proud to say about achieving what we have, be it solar panel generations, be it biophilic design integration, the structural system, smart technologies. This is in the design phase, but extended that even to the construction phase, be it incorporation of electric generators on site, adoption of green concrete, recycled steel in the project, and of course all that leading up to the highest certifications possible with this project. I would like to end saying that this, with all that vision, I hope it redefines mixed-use integration, seamlessly uniting public space, commercial office, retail, and data center within a single visionary structure. Every element that you've seen so far forms from its innovative bracing to BIPV fins, smart MEP system, low carbon facade, interior material, demonstrates a commitment to pushing boundaries and sustainability in architectural innovation for Hong Kong. Yet beyond its technical achievements, the project remains rooted in human-centric design, prioritizing the needs of Tung Chung's community, users, the daily visitors. This is not just a building, it's a bold statement on the future of urban ecosystems, where cutting-edge design and environmental responsibility elevate the way people live, work, and connect. Thank you, everyone. Thank you for listening.
Thank you, Ujjal, for the presentation. I think, it's a good example to show, how the architect take the lead to use low carbon material like terracotta with the client support. I think in terms of sustainability design, I think, facade material is one of the key factor, but I think, we also need to think about how to impact the public and human beings. So I would like to introduce the next speakers. Leo, associate from Inhabit, talk about the reflective solar glare, impact assessment and mitigation.
Thank you, Jovi. Good afternoon, ladies and gentlemen, and thank you, Zak, for the opportunity and platform. So I'm Leo. I lead the sustainability team in Inhabit. A big part of my work involves green building certification, like BEAM Plus. I'm sure all of you have heard of it or know about it. Well, another big part of my work is actually building physics, and it often involves environmental analysis or environmental studies, such as solar, wind, and thermal comfort studies. So, hence the reflective solar glare topic that I picked to talk about it today. So I will go right into it. So glare is a visual sensation caused by excessive brightness or brightness contrast that impair vision and cause discomfort for distraction. Well, it can be caused by either direct light sources or the reflection of light sources. Well, I'm sure all of us here has experienced glare at a certain time. So it could be a misangled spotlight in indoor environment. It could be a direct sun. And for drivers out there, it is the evening sun and the annoying high beam that comes up from nowhere, either in front of you or behind you. So these are all examples of glare that we experience day by day. But before I go into it, I would like to establish the understanding of some terminology that often associated when we talk about glare. So glare itself, just like what I talked about, is excessive brightness or excessive brightness contrast. Well, comparing to glint that you guys may heard about it, often associated with glare, it describes a continuous, intense source of bright light. For glint, it refers to a momentary, brief flash of light. So in this case, we often talked about glare. Well, we talked about glare more because it is continuous and affect a longer period of time. So another two terms that are often brought up and sometimes would be mixed up is luminance and illuminance. So luminance measures the luminous intensity in a given direction. It describes the light perceived by human eye, and the unit is candela per meter square. Illuminance, on the other hand, measures the luminous flux on a surface. It describes the amount of light falling on the surface, and its unit is lux. Well, so according to the graph, you can see here, light source emits luminous flux. Then the luminous intensity comes from the light source. It hits the object, and that is the illuminance. That is a measure of luminous flux on a surface. And how we perceive the object is called luminance. So basically, luminance is how much we lit the object. It is more related to building design, lighting design. And illuminance, I mixed it up by myself again. So let me come again. So illuminance is how much we lit an object. Illuminance is how much we lit an object. And luminance is how bright we perceive an object. Well, so then I'll go back to glare. So in terms of glare, there are two types of glare, or should I say two types of glare response. So the first response is disability glare. So it is a physiological response. It is a luminance resulting from stray light that's scattered within the light, which superimposes the location of task image, lowering contrast and resolution of the details. The effect is also termed veiling luminance by Hassel, which describes an effect of a veiling luminance as similar to that caused by hanging a thin veil in front of the eye. So basically, it means that at a certain time, the light is so bright that it basically has a thin layer of stray lights that affect we see clearly, and this is causing us to unable to see the thing that we want to see. Thus, disability glare. And the other one is discomfort glare. Discomfort glare is a little bit different. The response is a little bit different. It is also caused by a bright light, but then it doesn't mask our eyes. It can still produce after image, but it makes us to look away from a problematic light source without affecting the quantity of our vision. So the picture here on the left-hand side, you can see the left-hand side of the left-hand side image is kind of white. So it describes a thin veil that affects we see the object. On the right-hand side, you can see some spots of bright lights that makes us uncomfortable and want to look away from that spot of lights. So these are two types of glare. Well, for sources of glare then, as I mentioned previously, it could come from a lot of different sources. It could be glare from indoor lighting. It could be glare from outdoor lighting, basically artificial lighting. And the type of glare or the sources of glare that I would like to talk about today is reflected glare, the third one. And the fourth one is direct glare, if we are in an outdoor setting, not a lot that we can do about it other than putting up our sunglasses. So reflected glare from building. I think today is a good opportunity to talk about solar glare because the sun outside is really fierce. In fact, the weather now, I call it extremely hot. So imagine in this scenario, if buildings are reflecting the sun today, the impact will be very critical. Well, external reflected glare occurs when reflected light off a surface reduces observer ability to carry out their current tasks or reduce their level of visual comfort. The sun is typically the major source. The sun is the source of illuminance. That means the luminance that experienced by us, the observer, is the metric. So the component of a reflected glare include the solar factor, the building design, and the observer. For the solar factor, we couldn't do really much about it because it is the sun. And for the observer, let's say we are designing a building, we also couldn't do a lot about it because it is like the road and the surrounding adjacent building. So what we can do is the building itself. So let me talk about the building design. Well, in particular, material characteristics. Yeah. So by material, I mean mainly glass and metal. Yeah. Well, glass and metal are often more prone to causing intense glare because they redirect a large portion of incident sunlight in a concentrated beam. Here I show some of the hotspots on the building that can emit glare. And apparently, it is the glass surface, but not to neglect or not to, underestimate the glass surface that's come from the canopy, which is horizontal, and the metal facade they could also cause glare problem. And sometimes if they are slanted or if they are curved, could cause more problem. So why is that glass causing a lot of problem as well as metal surface? That brings us to a concept of reflectivity. Well, apparently, a lot of you, apparently reflectivity is a key factor. However, the type of reflectivity that exhibit by glass and metal, shiny metal in particular, is something called angular dependence reflectivity. Well, as you can see, the glass, as you can see the graph there, as the incident angle decreases, that is saying normal, going away from the normal, that you're looking at a narrower angle, the reflectivity increased drastically to almost 100%. Well, this is a phenomenon that is called angular dependent reflectivity. And then any material that has a specular reflectance component will display the same behavior. Apparently, the magnitude of reflectance may change for various glass product and coating. However, the angular relationship demonstrated here applies to all specular reflections. So I talked about specular. So what exactly is specular? So specular is how concentrated the reflected beam, or specular, basically, specular is a description of how smooth an object. Let me put it this way. So a material with high specularity is going to reflect all of its light in a very concentrated manner. So for example, we talked about reflectance. So you may ask a question, a white paint will have a very, very high reflectance, say for example 89%. But white paint is often not the cause of glare, solar glare, reflected glare. Because white paint is not a completely or a near smooth surface. Usually white paint has a little bit of roughness. That means the specularity of white paint is not high. As you can see, for a material that has a very, very high specularity, the reflection is going to be very concentrated. For a material that has relatively lower specularity, even though its reflectance is very high, say white paint, 90%, the reflected ray is going to be scattered or diffused so that not a single point is getting all the reflected ray. That means the glare problem will not be, as serious. So I'm going to move to talk about how do we look at glare. So for existing building, one could assess glare by visual inspection, just by looking at the glare with some protection, or quantitatively by a camera. You can actually photo a glare source and then put the photo processed by glare evaluation software, and it will give you some metrics. But for planned development, glare impact can be predicted using, again, computer modeling. And this is what we do. So one of the methodology and criteria is assessing veiling luminance. So remember veiling luminance, I talked about it earlier. That is the luminance that causes disability glare, like a thin layer of veil in front of your eye. That one. So recap that luminance is how bright an object appears to our eye. So veiling luminance basically measures the luminance and how we perceive that glare source. For veiling luminance, since it is luminance, the unit is candela per meter square. So according to Hazel, the veiling luminance criteria is 500 for motorists and train driver, basically road user. And according to another paper, it could be the criteria could be about 800 candela per meter square. So this is the criteria. And there are other different examples of veiling luminance value. Just give you an idea of what is level luminance. I would like to take a look into the formula of veiling luminance, because I think looking at the formula is a good way to know what are the contributing factors? So as you can see, veiling luminance equals to illuminance at the eye divided by the angle. So immediately, what I see, one of the contributing factor is where is the glare source. If the glare source is in front of me, then the angle is very small. The LV, the value, is very high. If the angle is large, that is not in front of me, maybe at the side of me, the angle is large, as it is the denominator, the value of L will be lower. So the angle where the glare source is contribute to veiling luminance. The other factor, of course, is the brightness or the light source. And the light source EV here refers to another equation, which means which are calculated by solar power times luminance efficacy and angular dependent reflectivity of the surface. So basically, it is like the brightness or the light source will be how bright the sun is, whether or not it's clear sky or cloudy sky, which is luminance efficacy. And again, we are talking about it being reflected off a surface, so angular dependence reflectivity of the surface. Our computer modeling, our assessment goes through computer modeling, which basically go through this process. First of all, we have our 3D geometry, everything, our project building, our surrounding building, terrain, and any architectural features. Reflective surface, we assign reflective surface, assign a particular material characteristic to them, for example, angular reflectivity. This is what we need to assign on the reflective surface, so the calculation does a job in calculating angles. The other one is solar data, apparently. The sun is the major source. The fourth one is observer location. We input observer location, it could be anywhere, and then we can we put all of them into a ray tracing engine, which is called radiance, and then we come up with a veiling luminance. So this is an example of the output. The model setup, 3D geometry, everything, and then through radiance, ray tracing software, we get reflected ray, we get a sun, we get a reflected ray, and then we do our result analysis. In this particular example, we can find that, probably couldn't see it very clearly, but apparently there are two orange spots. They are the exceedance of veiling luminance, which are found in early morning in April and August. We're able to, looking at the sun path, the annual sun path, time and date of the sun to calculate when and where the glare happens. So this is a rendering or a simulation result rendering showing the glare that comes from the building. Okay, so this is not the same project that I used. The same project that I used previously does not require a video, but this is from another project. So the result is not from early morning in April, but then it's from early morning in, I remember, November and another month. So this is November early morning baseline. So, glare is reflected off the building on the right-hand side, and then now this is with shading fin, so the glare does not reflect on the building on the right-hand side. Similarly, this is the baseline where there is no fin. You can see a really short time of glare happening in a building, and now this is mitigated. I'll let it play one more time. Right, there is it. After adding fin, there is no more. There is still a little bit actually, but this is reduced. There is it. No, yeah. Well, apparently it is not that really split second, but then according to the simulation interval, it is by hour. So yeah, it's not glimpse, it is actually glare. All right, so I would like to proceed to talk about indoor condition. So for indoor environment, things are a little bit different. Glare source can come from many sources. It could be direct source, if we direct glare from window and skylight. It could be reflection from adjacent building, just like what we show. It could be reflection from the building own architectural features, or the reflection from indoor surfaces like the wall, ceiling, floor, or even furniture. Therefore, and also, there could be a larger contrast in the indoor environment. It could be the indoor environment could have a really dark zone and another relatively bright zone. So there is some other thing to consider. And sometimes it is actually more critical because we are probably fixed, like all of us now, on one single position. I couldn't, not convenient to move away from the position. So avoiding this kind of glare is also very important. So rather than veiling luminance, another metric is introduced to take care of indoor condition, which is DGP. So DGP is introduced by Vivian Ngo and Chris in 2006. It has become a standard or industry-wide acceptable indoor glare assessment metric. In British Standard EN 17037, it is published in 2018, includes DGP as the method of assessing daylight glare. Well, as I will show later, it is generated as a hemispherical fisheye image and processed by the DGP evaluation to everglare. So applicability is suitable for indoor condition. It considers how much human eye responds to glare and improve the ability of metric to identify extremely light bright source. The glare, the criteria I've shown here, basically anything above, it is defined as anything about 0.4 is exceedance. So imperceptible or perceptible is fine, but then once one is reaching disturbing or discomfort or intolerable, will be something that we need to address. Again, I would like to take a look in this formula. You can see the formula is a little bit more complex, include a little bit more number and parameters. But what I want to point out is basically, again, it has something to do with the illuminance. But you can see that now, other than illuminance, the luminance of glare source, represented as LS over there, are considered together to form a ratio. So this ratio can address the brightness contrast. So the larger the contrast, the higher the ratio, the larger the contrast, thus the DGP. Well, angle consideration also replaced by a position index. Similarly, the more to the side gives a smaller value. In terms of the simulation, similar setting, but what we are adding in is the room setting and using additional evaluation tool, everglare. Example of simulation output, model setup, the fisheye image that I mentioned previously, and then the result. From this particular result, you can see, from this particular fisheye image, you can see the light is coming through, sunlight is coming through skylight, reflected off the floor, causing glare. So, you see some of the mitigation approach that we were looking at the previous examples, but then I would like to talk about what are the other options. So, basically, can I wrap it up real quick? So basically, avoid curved glass, facade, and shiny metal. Basically, we take the source and receiver approach. What we can do is to avoid curved glass, shiny metals, install sunshade architectural features, sandblast or diffuse glass that do not have a high specular reflectance, to have a lower specularity, and use, for example, PV. I didn't talk a lot about it because, there are anti-reflective PV in the market. From the receiver side, you of course can do all of that, like replace or use a diffuse glass, but then you can also just simply install a fabric blind or install anti-glare film. That could work. Those are general approach, but glare impact assessment at design stage can help your project to develop project-specific strategy to mitigate potential glare impact. So this can make your solutions much meaningful and much more cost-effective. So these are something that a design stage glare impact assessment can do. So you can adjust building deposition, you can adjust the position and size of PV panel, design a building specific device, the sensory device, use appropriate glass, appropriate interior design, as well as appropriate location for workstation. So number 5 and 6 is something that we have. Here is a swimming pool. Glare impact is identified at lifeguard location. What we do is move the lifeguard location. Turns out it isn't really possible, but like we do move it a little bit. But this is what you can do if you are like in a very early stage. You can basically move a lot of things around to avoid that, because by then you're no longer fixed in if you're still designing building, you don't have to like fix the occupant in one particular direction. Maybe that would be a very cost-effective way to solve this problem. So I would like to end my presentation by some personal sharing or just like personal opinion. So I think glare in Hong Kong is sometimes overlooked, but sometimes exaggerated. The reason it's overlooked is because there is no regulation. There's not statutory requirement in the performance metric. There is in prescriptive approach, for example, 20% reflectance. But there is no like a statutory assessment that has to be done. So it's sometimes overlooked. However, sometimes it is exaggerated. Well, some developer really want to look into it and really worry about receiving complaint. However, often cases in Hong Kong, the glare just appear for 10 minutes in the whole day or 1 day in a month. So, I mean, a glare impact assessment would be very useful in trying to assess whether or not your glare impact would be significant. So I hope this presentation can give you an idea what kind of glare, like what is a glare impact assessment, how can we design for to minimize glare. And I think, lastly, I think it's important to know to avoid glare, because we want our building to be admired, but not to look away from. Thank you very much.
Thank you, Leo, for giving us a presentation about glare, because, we normally, getting used to stress bar, the structural performance of the glass, but I think, this is something that, the public clear. So I think, is a good presentation. So I would like to invite the next speaker, Chen, founder of Anometal Aluminum, to talk about the long-lasting self-cleaning techniques for anodized aluminum. Thank you.
Whoa. Thank you.
Oh.
Okay, today's topic is remarkable application of innovative anodized aluminum architecture, self-cleaning and outdoor colors. As you know, anodized aluminum for facade has been used worldwide for more than 60 years. But there always a boring thing is natural tone or bronze and no other colors available for outdoor. Indoor, of course, a variety of colors, but those colors are made by organic anodizing pigment, which is fading out rather quickly under the sunshine. So, Anometal, to solve that point, we developed many new colors. And also, we invent a very, very unique way to get the skyscraper complex buildings maintenance-free. Okay, we introduced new Pure Wall Max. We register as a brand name, solar powered long life self-cleaning technology. Solar forever active. This is the one of kind. Okay. Pure Wall Max draws on the merits of the various method of develop the most optimized solutions. The oxidized layer, which we put on the surface of aluminum, which can decompose the pollutants into. Wait. What? I don't know. Sorry, I'm not familiar with this thing.
Send the what in next.
Okay. The oxide layer decomposes the pollutants into carbon dioxide, and water by photocatalytic activity, providing a self-cleaning effect over 25 years. That's the first function. The second function is residual pollutants will be washed away from the super hydrophilic surface, water WCA, which is water contact angle, in actual conditions, 8.9 degree by rain and wind. So this is 1 + 1, 2 function in 1 products. The oxide layer decomposes pollutant into carbon dioxide and water by photocatalytic activity, providing a self-cleaning effect over 25 years. Anometal developed this unique method, which formed a single-phase titanium crystal oxide on the surface of aluminum, inventing a purely inorganic self-cleaning oxide layer. When material exposed to the UV in the sunlight, the titanium dioxide will release electrons, and from the electron holes will react respectively with oxygen and water in the air to generate a single oxygen atom and hydroxyl. With strong decomposition and oxidation capabilities, these two will decompose organic inorganic mixed pollutant on the surface of the layer into carbon dioxide and water. And water can easily permeate under the dirt and lift them off, letting the stains flow in the water, so that those stains can be further washed away by rainwater. It's how it works. Okay. This is experimental we did. We use a very strong UV lights. Okay, it's about 10, 20 times than the standard UV lights to speed up the result. Pollutant indicator we use is methyl red. Pure wall treated anodized aluminum is panel figure A, and the conventional anodized, which is sulfuric acid anodized for building materials, is panel B. After 6 hours exposure under the strong UV lights, the panel A, you can see there's a methyl red color, the pollutant indicator, kind of fading out, still have some leftovers. The right side, conventional anodized aluminum panel, virtually no change. After 30 hours of accumulated exposure, UV exposures, the panel A with the self-cleaning, the methyl red disappears, completely disappears, and the conventional still remains. This is a test actual under the sunshine. This is a project in Chengdu, Sichuan province. The white one in the center is our Pure Wall Max solar. This is on the wall about 1 year. It's clean and neat. Around that is a PVDF coated aluminum panels. It's kind of gray shade, losing some kind of gloss. Right side is a PVDF coating, also coating panel aluminum with a large project in Shanghai. You can, because the angle, the dirt or the stain, or stack up on the surface. Second function. The residual pollutants will be washed away from the superhydrophilic surface, water contact angle equal to 8.9 by rain and water. Well, theoretically, with the Chinese government standard or knowledge from the worldwide, also provided by PPG and AkzoNobel, those painting company, they provide a painting called self-cleaning. The ability is they use the self-cleaning is using hydraulic result as wettability. So let's say hydraulic is let the rainwater to wash away the dirt. When water contact angle, which is a drop of water on the aluminum surface, where the water contact angle is less than 60 degrees, it's called hydrophilics. Hydrophilics is certain level, can provide a certain level of self-cleaning. But when the water contact angle goes smaller, which is superhydrophilics, the wash away effect goes higher, gets stronger. And ours, after this actual test, is 8.9 degree, which meets the standard of superhydrophilic, which is way better than the regular hydrophilic self-cleaning. Work principle of superhydraulic is our water drop on the anodized aluminum. You will not see a drop form. You only see a thin water layer, and so those layers can easily wash away dirts. And those dirts has been photocatalytic broken into dioxide, carbon dioxide, and water already. This is a report that we got from the Chinese National Architecture Material Test Center. There's a test report. The minimum water contact angle 8.9 degree. So wettability water contact angle indication. This is 8.9 degree. This is the actual demonstration. On the left side is regular anodized, and right side is our Pure Water Max. You can see from the right side, the water form a layer of it. No drop, no water drops, and no, shrinking of the water stream. And the left side, it's a regular anodized. You see water drops. When the rain stops, dry out, you will see dirt on the surface. It will gradually stack up, and this is not. So the technology that combines the two powerful self-cleaning features, the inorganic oxide layer consistently decomposes the pollutants by utilizing the photocatalytic activity, providing a self-cleaning effect over 25 years. And the residual pollutant can be, which residual pollutant means non-organic portion of the pollutant. The residual non-organic pollutants can be washed away from the superhydrophilic surface by rain and wind. Pure Water Max can greatly enhance the anti-pollution performance to the facade, and almost no need to clean and do any maintenance. This world-leading epoch-making technology will surely become an exciting choice for the architectural industry, especially for the supersized buildings. We have 27 years of experience in surface pretreatment. I'm talking about the colors. Interior organic dyeing, well, it's not so important because everybody can do it. This color can be designed according to designer's intention. Any color can do it. Exterior organic dyeing is only the yellow, so you get the lead champagne to very dark gold. Okay, this is also easy to do. Underneath is our strength. UV stable electrolytic coloring. This is gray, authentic gray. The gray color is non-available in the facade industry until today. So we're the first one in the world. It developed and invented technology to the gray, UV stable gray. And these are browns, copper, darker copper, warm copper, aged brass darker, and then forever black. At the moment, we're working on the forever white colors. White anodizing is also never available in the industry. So gloss meters, gloss spectrum, we can do anodized aluminum from 10 GU unit to 800 GU. 800 GU is basically a mirror surface. UV resistant exterior colors. This is great. Like I said, this is a very new in the world. Nobody else can do that. The only company we know can do gray anodizing is a German company, a batch anodizing company called Aludecta, but that's a batch. So you got very different colors from gray shade from one panel to the other. We do coil form, it's much more stable in color-wise. This is aged brass. You can see these from light to dark. Dark is like a chocolate. This is a warm copper because the real copper is kind of, the color is very warm, very hot, kind of red. So some designer want us not so strong, so we'll blend into some yellow in it. So this is a twin colors, a red and yellow blend. So this is a warm copper. All the color I'm talking about are UV stable. This is the project we finished, designed by Ahmed architects, 25,000 square meters. This is a warm copper. Just finished few months ago. The ring looks like a big copper ring, but it's anodized aluminum. This is a real copper color. Copper is kind of red tone, so it's light to dark. It's red copper. So for 20, 30, 40, 60, 70, from light to darker. This is a traditional electronic color, the anodized aluminum. This is bronze. This color has been used worldwide in the building industry for more than 60 years. So bronze 20 to bronze 17. That's nothing new, but just it can be used outdoor. So we just indicate it. This is one we done at the Yangtze International Conference Center. Morphosis, designed by Morphosis Architecture. There's a B30. It's a very light bronze. You see the color difference we did? It's proud to say no color difference. Project portfolios. This is a natural tone. We finished 86,000 square meters. Satin finish. We also did the little gold. The little gold ring. That's an anodized gold color outdoor. This is also Ahmed Architects, Shanghai Astronomy Museum. Those two are natural tones. To help the designer to save the cost for the building owners, for this particular project, we developed a diamond cut, which is aluminum can be not square, cut out it's a diamond shape. So material efficiency has been increased about 10%. And use less material to build more surface on the wall. This is Guangzhou Yunzhu International Conference Center Hotel Complex. So it has 4 hotels and 1 conference center, 4 5-star hotels and a big conference center, 10,000 square meters. For that project, we did the 3 colors. Natural tone, all the technical unit. Natural tone is regular anodizing. This is an electrolytic colored bronze. And this is a champagne. This is a inorganic dyeing. This is dyeing technology. It's not electronic coloring, but it's inorganic, so can be stay outside without any problem for 50, even 100 years. The champagne gold. This is a Zhejiang centers. Why we put this on it is we developed quite some time ago a surface called the foggy mirror. You can see the foggy mirror. Foggy mirror anodized aluminum. The result is when in the morning and the nighttime, early nighttime, these areas usually have fogs and the autumn, spring, late autumn, early spring, and winter. So when the autumn, spring, winter, the fogs shows up, the building itself, because underneath is those old portion are panels, are those aluminum panels. So you see this is a same position here. You can see that. So the building looks like a floating, like an airship, spaceship, floating in the buildings. So this is a very interesting design, using our material characters. This is here, Hong Kong University, Hong Kong Education University Museum, Hong Kong Museum of Education University. It's a small project. This is we use semi-bright. It's not so like a foggy mirror, but we give some enhance the glossiness. So this is a semi-bright finish and it has aluminum panels. This has been done, I believe, was 10 years ago. We consider as a pioneer and a leader of the surface of aluminum pretreatment. This is our WeChat. So if anybody has interest, please take a photo. We have a booth outside in the hallway. If you have any question, you can come out and ask us, especially for those special color and special self-cleaning functional materials. Thank you very much.
Zach. Thank you, Fan, for giving us, the latest technology of anodized metal. I think, it's pretty interesting. I think, it would be good, to for us to know, more about, the self-cleaning. I think, it's nice. So I would like to invite the next speaker, Shevonne, Market Segment Director, APAC Ceiling Glazing and Façade from Tremco Construction Product Group, talk about deep energy retrofits, the future of sustainable buildings.
Thank you. I'm the last speaker for today. Hope that you are
still alert? Okay, so today's topic, I'm going to talk about deep energy retrofits, the future of sustainable buildings. So before I go forward, I would like to briefly introduce our company, Tremco. Tremco has been in the construction chemical company since 1928. It is origin from United States. Today, Tremco is owned by RPM Incorporated, a Fortune 500 publicly listed company. In Asia, we have 5 different regions under one MD, right? And then in Hong Kong is our Greater China office. So we have a team in Hong Kong to serve the market here. What is the key value propositions of Tremco as compared to other construction chemical companies? As of today's, we are aiming on to become the first evolutions in the green sustainable solutions provider. Our manufacturing products are in green sealants, and we are aiming on future-proofing products solutions like giving not just a wet seal, also the dry seal, the membrane, and so forth for the cladding industries. Our role in the market today is to innovate, continue to lead, and continue to provide future-proofing solutions. So this is a very brief walk about who we are today. And the topics that I'm going to talk about today is deep energy retrofittings. Deep energy retrofittings is no longer optional. It is a cornerstone of future-ready, sustainable building. Study has shown by holistically upgrading building envelopes, MEP systems, and operational performance, deep energy retrofits deliver a quantum leap in energy efficiency. Control, giving us the comfort and also the life cycle that we desired. The approach of this especially critical for aging commercial and also public buildings, which can offer more than 50% of energy savings as compared if we just to do the conventional retrofittings. Deep energy retrofits in Hong Kong, it is a form of comprehensive building upgrades. The reason is because the city here is populated by high-density tall buildings, high-rise environment, right? And also a big aging building stock. In 2021, the Hong Kong Environmental Bureau has indeed set a new goal of achieving carbon neutrality before 2050. Why do we retrofit now? Right, as I mentioned, we have an old stock of buildings around in these regions, right? Restoration buildings with energy conservation in mind is not only a massive undertaking. It requires a holistic approach for us to work together as a team to develop a sustainable, actionable solutions. And this hopefully will help to create a better carbon footprint. Today, retrofit is carbon strategy. How is it in a building retrofittings impacting the carbon emissions? Building renovations, especially in densely populated areas such as Hong Kong, are pivotal in reducing embodied and operational carbon emissions. Operation carbon emissions are referred to those carbon that is churned out by our functioning active buildings, like as if from the cooling and also the heating elements from the buildings. By retrofitting occupied buildings, on the other hand, actually this can really save 50 to 70% of the embodied carbon emissions and reducing energy consumption of up to 40% in constructing the same as compared to reconstructing a new structure. Fun fact, right? What can Hong Kong do more in advancing a net zero situations, right? We are referring here, as of today, we have more than 16,000 high-rise tower and more than 90,000 concrete high-rise residence tower around Hong Kong Island itself. Buildings in Hong Kong consume about 90% of the total electricity, and this, in fact, generates 60% of the carbon emission. It is a big chunk of number, right? The substantial energy demand not only constrain the economic development. As I hear just now, we have upcoming more data centers coming up, right? But we need to have enough energy to supply. So perhaps Hong Kong one day can be the hub of a data center if we have more energy to supply, right? So when we talk about retrofitting buildings, right, in the concept, they have separate into the two retrofittings. So first of all, we work very closely with our stakeholders and try to understand what exactly is the aim that they would like to achieve. If the client is sharing with us that they would like to achieve just a mere more than 10% energy efficiency, that we call a shallow retrofit. But if it, in the other hand, that our client would like to achieve more than that, more than 50% of the energy saving and help to improve on the carbon embodiment, in this, we do deep dive into the deep retrofits program. How can we be of service of the deep retrofit program? So the package that we do, actually we look into the thermal envelope of the buildings. Deep energy retrofits involve advancement of thermal envelope, aka sealing the exterior shell of the building, close it up, right? Building envelopes upgrades can help to provide actually the best, highest return of investment in the long-term performance. What are the common gaps in the building envelope when we do a deep dive of the facade of existing buildings? Oftentimes, we will find uninsulated wall, air leakages, thermal bridges required, and sometimes, basically, we will tell our client, you cannot manage what you cannot seal, right? If there is anything that you need to seal, you have to seal it either by the wet seal or a gasket or a dry seal or a membrane in whatever form you can. That will be help to enclose the building envelope. These are the 6 key driving technologies adoption in deep energy retrofittings. Oftentimes, we will see a lot of time the phase 1 of the retrofittings where the money goes will go into the mechanical systems, and then they will look into renewable energies integrations and also the smart integrations. However, building envelopes such as facade, roof, and window oftentimes are the less in the considerations, right? So we wish to urge that architects and consultants and the building owners to start to look into the old stock of the asset and do some energy assessment of the facade. So some of the packages for the facade that we help to look into, often integrated envelope solutions, we help to solve the pain point of air leakages, thermal bridging, thermal transitions, and envelope disjoint. So if you have any situations that you would like to speak with us, this will be some solutions that we can offer. Here is examples of Bank of America in Dallas, whereby we do a customizable solutions where we walk the journey together with the client for more than 10 years. I will showcase a snapshot of the video for self-explanatory.
To Today we're going to talk about the Bank of America Tower you see behind me. Currently the tallest building in the Dallas-Fort Worth Metroplex. Was built in the early 80s, completed in 1985.
10 years ago, we reached out to a local consultant, had them take a look at the building and put a 5-year plan together of changing the seals out on all 18,000 panes of glass.
Well, after the call from CDC, I reached out to Tremco's design engineering team in Ashland. Through Peter Poirier, we found out that we had actually provided the gaskets for the original installation.
So I looked in the mezzanine, which is this dusty old place up and above the ceiling, and we had the files. All of the information that he had was laid out perfectly in those old manila folders up there.
That was actually a peace of mind for the owner. He felt like if the original gaskets from Tremco had lasted this long, that he couldn't go wrong with going with a Tremco solution again. The exterior gasket originally was a neoprene sponge gasket, which was in place before the glass went in from the interior side of the building. So the challenge is, how are we going to replace that gasket without removing glass, without interrupting any of the occupants in the building? We offered up what we call our poly wedge design. The poly wedge is very unique in that it's got some angularity to it, but it is a dense profile that can be inserted once the old gasket is removed.
The problems that we came into was that the initial design is a little bit too heavy, so it was too hard to drive in.
It's very important we don't break glass. They were very instrumental in getting the gasket to the correct sizing to where it was efficient for us to install, and it didn't allow too much pressure on the window system during that installation.
So if you get a PLI that's over 7 to 10 pounds, I believe at 15 pounds, it can start to break the glass, especially in restoration. So it has the old glass with the metal that holds it instead of the polyisobutylene. So there's no silicone containing that glass, and it's a lot easier to break. And if it's too light, it's just going to leak more than it already has been.
The contractors used that material in the mock-ups. Come to find out that the one leg of it was a little too long. It was butting into the setting block and kind of giving a little bulge look.
So we shortened that up a little bit, and it was a perfect fit for their restoration project that they had down in Dallas.
Did that. Second round worked perfect. I've been using it ever since. I don't know how many rolls. If I remember right, there was like 80 some miles of gasket that's going to be used on this job.
That relationship of them being here every day, doing the inspections, making sure that it's all done right, and with no interruption to our facility or our tenants.
A lot of these buildings in this area have that same sponge gasket on the exterior of the building, and so this poly wedge solution will be a great one for customers to look at that is going to be effective and be a clean solution for them.
Thank you. With this outcome, actually, we have done the latest survey. We managed to help the asset to save 42% of the energy saving just by replacing the customizable gasket for the building, and the return of investment is less than 7 years. So actually for us, Tremco today, we do understand the energy consumptions and energy reductions that a facade is required, right? How can we help in be part of the stakeholders, right, or the members, to enhance the durability of the facade and to help the consultants to work together to create a more flexibility or change of function or change of use in a short period of time. So we also understand that there are a lot of requirements on the sustainability scorecard. So most of the solutions and the undertaking products that we produce and we promote, they have already been tested with the sustainability taken into considerations. And as we are working into a facade, so fire mitigations and the facade in the facade requirement is also one key crucial important for us to consider. And also some part of the world, we are looking into hurricane and a high wind load area. So we do have experience and solutions for all this. For the insulation, for the steel framing built-up facade, these are the facade, the solutions that we can help to work closely together with the stakeholder, with the marketplace, especially for the retrofitting projects. Here are also some of the examples or case studies that we have conducted, that we work very closely from the inception of the project stage with the architect, journey together with the building authorities, and then eventually put it up into a building. And this is the case study, a project in California, USA. So this is a 2-block of multi-family buildings, which is more than 70 years old, that they require refresh and rebranding. So what we have worked together to propose is to work closely on a modular prefab panel fabrications, and then we work closely with the insulations, provide the insulation panels, and then that actually help us to be part of the comprehensive team to help the building to create 40% energy savings, and of course to create the comfort in the for the occupants. Another case study is in Washington, that this is to reduce the emission and improve the efficiency, where we can get the ROI insights of 40 to 60% reductions in the carbon in the energy use, and the return of investment is between 7 to 10 years. So this is just a chart to showcase some other renowned projects that we undertook in France, the Louvre, the Church of Our Lady Dresden in Germany, that facilitates actually the old facade, the historical facade. The Shark London, this we involve in the fire stopping, sealing the interior of the fire safety of this building. So this will be my last page. As a final thought, consider deep energy retrofitting as a business imperative. In the evolving real estate and construction ecosystem today, deep energy retrofitting is a strategic lever, not just sustainability, but for competitive differentiations. Those who lead in deep energy retrofitting will own the future of high-performing, climate-aligned buildings. It is critical priority that requires focused action and resources to achieve, often impacting multiple disciplinaries and required project-wide alignment. Essentially, it is something that I personally believe a business must do to thrive. Thank you. My name is Shevonne. I'm part of the team from Tremco CPG, Asia Pacific. Thank you.
Thank you, Shevonne. I think, it's quite a big agenda for, retrofitting, the building. I think, not just, simply repair or replace the material. I think, it's good to really have a more holistic solution to have a facade refurbishment to enhance the performance. So now we are moving on to the panel discussion. I would like to introduce the moderator, Lisette, the Managing Director from IXO Partners, to take the lead of this section.
Okay. All right. We're the final panel for today, so thank you for staying with us. We have Ed Farrelly from Marsh. If you'd please come up. Yep. And I'm going to sit here on the, you go here. Yeah. Can we have Woody Chan, please, from Link? And Grace Kwok from AEC. Yeah. And Marius Mariano from Inhabit. One glass of wine, you've got one too. All right. So I have extensive notes. And the reason I have extensive notes is because this is a topic that is very close to my heart, climate risk and resilience. So I just want to start by saying, obviously we've heard a lot today about materials, about codes and standards, about technological innovation. Facades is obviously a risk-driven industry. It's kind of one of those elements as to why we're here. What we wanted to do today was talk about the holistic risk that is very much front and center of our response these days, and that is climate risk. Now, climate risk for facades is something that stands to change everything that we do, to change the standards that we work to change the materials that we use, and to change the systems that we deploy and design with. What we want to do today we have two people that are not from the facade industry, so I'm going to attempt to use plain English to the best of my ability. But if Ed and Woody have any questions about terminology, please pull me up. So, climate risk, there are two moving parts. There is the gradual increase of temperature. There is the gradual increase of humidity, of hotter, longer days. There is also the extreme event-driven risk, so typhoons, flooding. Now, the second is something that is primarily being looked at in the insurance sector. And we all know, because we read the news, that there are increasingly areas globally that are becoming uninsurable or deemed to be uninsurable. So that's one aspect of insurance. Now, the other aspect of insurance that we also know is professional indemnity insurance. Now, that has not yet, as far as I'm aware, been impacted by climate risk to the extent that they probably will become so. But it is definitely on the increase due to other risks that we're seeing. So cladding fires being the prime example of that. So on the backdrop of these two types of risks, we have a case study from Link and Marsh and AXA that provides a really good grounding to understand what climate risk is and how really effective measures might be able to be wrapped in through existing buildings, and then have a reward risk component element. So have an insurability element that links a reward incentivization. So what I want to do, because I'm not here to talk all day, is have Ed start from Marsh talk about risk and insurance. Over to you, Ed.
Okay, thanks, Lizette. Firstly, apologies to everyone here. Thanks for hanging around, by the way. The last session, I was just looking at the agenda. You started at 8 o'clock this morning, and now you got to listen to an insurance broker at the end of the day, which is not ideal, but I promise not to try and sell you insurance. But hopefully I will be able to provide context. And then, Woody, maybe you can talk later about the case study for which we produced the white paper. And there's, Lizette, you've outlined two types of climate risk, that kind of gradual change and then the events-driven one. So maybe I'll just approach them separately and focus first on the events-driven change. So what I'm going to talk about is property insurance, and globally, the global property underwriting business up until 2022 had suffered a loss every year for 10 years. So the industry as a whole around the world, every single year they suffered loss. Now, insurers did make money, obviously, through their asset management business and through other lines, but property suffered the loss. There's different levels of insurance. Now, insurers, they will pass on the risk to reinsurers. Reinsurers, for a number of years up till, again, end of 2022, their return on equity was at or below their cost of capital. So they also were losing money. So the obvious answer to that is that insurance premiums should rise, and they did for a number of years. In Hong Kong at the moment, they're not. They're falling on property insurance. So anybody who's facing a renewal on any property, talk to your broker about getting a discount on what you're paying. But rising premiums is not a long-term sustainable business. In some parts of the world, you're not allowed. You're exempted. Yeah, the extent to which it is in California, for example, after the fires in LA, wasn't it? So the extent to which they can rise is capped. So now, what's the reason for all of this? It's the increase in more extreme weather events, the increase in the damage they cause, and also the frequency. And also there's a change in population movements. If you look at the demographics in certain parts of the world, that there's more value at risk. So the areas, if you take, for example, the US, the areas that are most at risk, the Gulf states, Florida, California, that's where people are moving to. That's where they're building their homes. So there's a real problem the insurance world is facing there. So going back to 2022, after all of these losses, what did the insurance world do? First of all, they looked at the models they were using. They got NatCat modeling. They recalibrated those and refined those to make them more accurate.
NatCat, for people in the room.
Sorry. I had to throw in some terminology. So maybe after, because I'll lose some of the facade terminology. So that's one thing they did. Also, valuations of property. So the valuations, they asked for updated and accurate valuations. These are different from market valuations that surveyors will carry out. So they're pure reinstatement valuations. Again, insurance is there to reinstate you to what you had before and after a loss. Also, risk surveys. They ask for risk surveys to be carried out by risk engineers. And then for those, the recommendations from the surveys, for those to be acted upon. And they would insist upon those. And there's a laser focus on data. So the COPE data, which is submitted in the insurance submissions, which is construction, occupancy, protection, and exposure. All of this data, if there are gaps in the data, they'll assume the worst and then they'll price accordingly. So all of this is happening, and kind of to sum that up, what the insurers were asking for, they're asking what is the insured doing to mitigate the risk? So it's like you buy car insurance, but you don't leave your car unlocked.
Yeah.
Okay. So when there is risk, you need to do something about it. You need to manage it. You can mitigate it. You try to stop it. You can transfer it, which is insurance, but you must do something. You can't just ignore it because eventually it will appear in your balance sheet. I often, if we have losses year after year, two things will happen. Capacity will go down and prices will increase. And the capacity issue, it's not an issue in Hong Kong just at the moment, but a number of years ago it was. I kind of use the analogy of, if you think of a popular nightclub, now I'm too old for nightclubs, but back in the day, you think of a popular nightclub, it was kind of one person would come out and one person would go in because it was full. And who'd get in? The best looking and the best dressed people. The job of an insurance broker is to present the risk in the best possible light so that it gets that capacity. Insurers will look for the best risk. So that's what's been going on in insurance. And on sustainability, I've been asked the question. It's actually Calvin from Link Asset Management asked me the question before we started on this project. He said, if I've got good ESG credentials,
does that buy me good insurance?
Should that impact on the insurance? Because if I've got bad credentials, I own a coal mine, for example, I'll get hammered on my insurance. So how would you flip that coin? If you've got a green building, your net zero or carbon neutral, that won't impact on your insurance. You won't benefit from it. And basically because it doesn't change the risk profile of the asset. So that's, transitional risk from climate change. What insurers and underwriters look at is physical risk. And again, that's what Link Read addressed. So that is that kind of events driven. Now, with this kind of gradual change, the increase in heat, the increase in humidity, really insurers are very reactive. They respond to losses and frequent losses. So if the losses haven't occurred yet, they won't act. And if you think insurance policies are for 1 year, so that's the kind of time frame they're looking at. Investors also, unless you're a long-term landlord, investors may have a time frame of 5 to 8 years. So again, it's quite short-term. So not much has happened in that regard, but what we're starting to see and a lot of demand for is studies on probable loss and the financial impact from probable loss, because the probable loss is increasing year after year at a rate faster than we appreciate. And that will eventually have an impact on the insurance world.
Very interesting. So we'll come back to that operational kind of risk and gradual air infiltration and those risks, I think, with Marius. But first, I'd like to move to Woody to talk about the Link asset management work and how that unfolded. So what was the journey for that?
Sure. Following on from Ed, let me start by casting your minds back to almost 2 years ago now. For those of you in Hong Kong, you'll remember that we suffered a catastrophic rainstorm event in September 2023. Highest hourly rainfall ever recorded, 1 in 500 year rainstorm event. And Link Asset Management was one of the most badly affected property companies. Those of you watching the news would have seen our mall, Temple Mall North shopping center underwater, along with, of course, the adjacent MTR station. Those have since become the kind of poster child images that people keep using at climate risk forums. So
we don't have it here, Woody. Should we have?
I've had that photo on the screen before in this exact event. And so the extent of damage was, of course, quite devastating. It was around 3.2 meters of flooding, so almost 3/4 of this ceiling, I would say. 8 of our tenants were affected. For almost 2 months, they couldn't do any business. And naturally, the loss for us and an extent of this, the insurers, is large. Off the back of that, the first thing we did was to entirely revamp and upgrade our response in terms of climate resilience. So not just in Temple Mall North, the shopping center most affected, but across our portfolio, we invested around 5 million Hong Kong dollars into floodgates, IoT sensors, upgrading the drainage covers, something even as simple as changing the cover from something with slits to something with larger holes to increase the efficiency so that even if there's blockage, there's more flood water leaving. There are even softer measures like sandbags and ensuring there are sump pumps available for our staff to use, but also the engagement side, making sure that our staff actually knows how to use the sump pumps, know when to put up the floodgates, which equipment is the most important to protect. So that's the whole suite of measures that we put in place, even relocating the pump rooms where needed from the basement floor to upper ground. So that's the first part, which is the measures we have put in place. But harking back to what Ed was saying, how do we then present that and say that we have actually reduced our risk?
So you took it upon yourself to perform all of those measures without knowing yet whether there would be an insurance premium reduction?
Yes, because we have to. The base case of an asset manager
is the balance sheet recognition.
We have to make sure that our assets are protected, that our tenants, that our communities visiting the shopping centers are protected. So that is something it's a fiscal and social responsibility that we must fulfill. But the second part of that is, how do we derive value from this? And the first thing we did was we looked at our insurance premiums from the past 5 to 8 years. And the interesting thing we found was after Typhoon Mangkhut in 2018, a super typhoon that some of you may also remember. It was probably the worst typhoon we've had in the last 10 years. You have windows smashed and even facades were being affected. After that, our premiums jumped up by a lot, and that was a quite alarming thing for us. So we were like, how is this going to happen again after this rainstorm event? And that triggered us to immediately reach out to Ed, Marsh, our broker, and say, what can we do this time? And so the response was, we, along with Marsh, organized an insurance roadshow for our potential insurance panel. We got together around 25 insurers in the same room and essentially told them, this is what we have done to our entire portfolio in terms of adapting to climate risks, not just the extreme events now, but we have also done assessments with scenario planning in terms of different emissions scenarios, and we are safe because of this, and this. Some of the measures that I have just elaborated on. And off the back of that, 18 months on from the flooding event, in the renewal just passed, we managed to get an 11.7% reduction in our insurance premiums, with a provisional second-year renewal of an additional 7.5% in premium reduction if our loss ratio does not exceed 60%. So not only did it not go up drastically, it also it went down. So that's something that we're hoping to drive the industry towards, not just in terms of resilience side, but the engagement with the insurance industry for a win-win solution whereby we can help them reduce the exposure and we can derive some value from our resilience measures as well.
Yes, just to quantify or to reinforce the impact the measures you put in place had on the insurance. So Woody said 11.7% reduction in the insurance premium. The Marsh Insurance Index for Hong Kong at that time showed the industry average of 3%. So it's a very good way of just comparing the efforts that you made, how that translates into in an extra discount.
Right. Okay, so we have the groundwork of what adaptation looks like. What I'd like to do now is get Marius to talk about risk. Marius. So what is risk for us, as facade people? And have you heard of climate risk before? Have you worked on a project where someone's asked you about adaptation measures?
Well, in our industry, we mostly deal with technical, you know that list.
I do. A leading question, Marius.
Yes. And it's quite surprising that this kind of things trickle down to insurance, the valuation, the risk, and etc. I thought it was just about, income from the building.
Value, right? Yeah.
Yeah, it's a value. You made a good-looking facade, make it famous, and make sure that it complies with requirements, and that's good to go.
And then it's good to go. Yeah.
But now it's an eye-opener that there's some talks underneath what we know, which these two gentlemen just opened up. And I just want to start with what is the primary function of facade. So, okay, let's go to the basic. The primary function of facade is to shield the building and its occupant to against any external elements. The second function is to make it controllable climate to the occupant as well. So external is covered by the facade and also the living condition of the end user. And of course, the third one, which we thought is the important one, is to make the facade looks good. We're talking about Henderson this morning. We're talking about the project of SOM. Looks great, following the code, etc. But right now, at the end of this talks, we're talking about what is the risk associated with those design. Well, for start, I think facade is becoming more complex nowadays. Facade is part of architectural history from ancient Greece to Renaissance period, and then use of glass and metal started during the Industrial Revolution, and that one takes a long time up to the early 80s, where in the early 80s we defined the system on the facade. We have
currently we have three types: fully unitized system, stick system, and the hybrid of the two, semi-unitized system. So from 80s to early 90s, the golden era of curtain walling, I worked for a contractor. I even worked for construction before I worked for contractors. These three systems are the main key system, for the facade.
Yeah.
And at the time, there's no requirement for sustainability. It's unknown. As long as you comply with those two functions, like shelter and occupant
comfort.
Yeah, comfort.
Yeah.
And your facade looks good. You take a picture saying, "This is my office, grade 8 office."
Great. Yeah. Great daylight.
Yeah, great daylight. Yeah, we have a wide view, etc. Then it's okay. But as we move on, technology moves on, the regulation change. I will talk about energy efficiency because. Like for Hong Kong, high-rise skyscraper are, it's becoming so prevalent. I work here because of this. I mean, when we started, we even have a curtain wall system that even in IGU form, basically just comply with those three requirements. But in the 90s, it started to change. Glazing industry start talking about low E coating, thermal insulation. There's a lot of requirements regarding
acoustics, fire,
etc. And then some additional element that they want to include: lighting, dynamic facade, automatic openable venting system, etc. So these are additional elements that will be included in the risk later on. Nowadays I call it modern and contemporary era for the facade, where you don't only comply with the structural requirement, you have to comply with sustainability, zero carbon emission, etc. And this become more complex in our industry. We have to look for alternative materials. Previously, we just using glass, aluminum. I even remember on one of my projects, the minimum requirement for coating is just two layer of coating. That will not work nowadays.
Powder coat.
We specify 4, and still it's probably not enough. Move it forward. So we have to look on some other materials, some other new technology. The problem is, at the moment, unlike for all those old materials where we see it for decades, the new material, there's also a risk. We don't know its durability.
Yeah.
And it's being integrated to facade, photovoltaic panels, for example. Of course, there will be mechanical and electrical connections, and it will be integrated to the facade system. And it will involve the risk. Now, for the risk, I listed type of risk for the modern facade system. One is the extreme weather. So, of course, there's a regulation, there's a statutory regulation. So I think this is a tick box. Hong Kong recently changed the wind load. Now we're using the version 2019. The calculation for ed zone, etc., is more stringent nowadays. And in fact, Hong Kong has one of the most stringent requirements in terms of wind load.
Yeah.
Some of European architects that I work with, they say, do you really want to build this in Hong Kong? It's too stringent. So that one, I think it can be mitigated because there's a regulation, there's a statutory requirement governing it. The other one is the increase of rainfall in moisture. This is the sign type of risk. And I can mention that even on the early 80s and 90s, we have 3 systems of facade. And if you're not very into much detail, up to now, it will start to leak. The moisture content from internal to external and vice versa is not mitigated properly. And it's good that Shevonne talks about the solution. So this is design based of risk. And then the other one is extreme temperature. Thermal requirement, I think there's a thermal requirement recently, but Andreas previously talked that the requirement probably have to step up a bit more.
Yeah.
And I agree because some of our, we also done in Inhabit, we also done some building inspection. And I will not mention which project, but we done some inspection way back in 2020, 2021. It's a relatively new building, and there's a complaint from the end user that, there's mold inside, etc. And the facade is being completed by a renowned contractor as well. They have a good track record, but still, there's a lot of condensation, not only on rainy season, but even on summer.
Yeah.
So we have an inspection on that one, but we found out that the implementation of the system is not fully addressed.
Yep.
There's some shortcuts that happen. We think
There are no shortcuts, Marius. Everyone's doing the best.
and we done a lot, and I think because the building management is really stressed on that.
Yeah.
Because it's about to be, I think the insurance is about to be renewed. That's why they've done it in a hurry. But those are the risks. And then the additional risk that I can add is about the new requirement, the energy efficiency, carbon footprint, and sustainability requirements. So this means we have to integrate new material or new technology to the facade. Then this is something that's added to the risk in terms of climate change, because we already have a lot of challenge on structural design and mitigation of moisture. So what can we do about this? I mean, well,
I think Grace has the answers.
Yeah. Well, I'd like to mention also, it is correct, Shevonne mentioned that about 80% of the building here in Hong Kong is old.
Yeah.
It's very old. There's a lot of office building, commercial building that I think if you make an analysis nowadays, it will not pass with the requirement. There's no energy report.
Yeah.
And even some of the building is still using 1980s wind load, and there's 2 iteration already. So if you do evaluation, structural evaluation of that project, those building, I don't think it will pass nowadays. Design-wise, same. Maybe it's good for the first 20 years of its life, the building, I mean. But now with that requirement, I don't think it will also pass. So how to do a mitigation to lower the insurance cost? Retrofit. We done a retrofit in the mid-80s in Shevonne. It's a gold building on the corner, and my colleague talked about reflectance, and it's one of the concern of the we do a retrofit for that one. We're commissioned to help with the minimal interruption to the operation. So basically, we retain all the mullion strands of thing, and we put a more thermal efficient glazing system. We change the fire saving, the thermal insulation, and I think it has been assessed that it will be good for another 25 years. So the value of the property shut up as well.
So if the value goes up, then the insurance goes up, unless there's a climate risk study that shows adaptation measures have been wrapped in, right?
Yeah.
That's the everything goes up.
Anytime you place your insurance, you got to declare the value of the asset.
The
other thing, and the last one, buildings department in Hong Kong, and this is good in terms of risk management. They require now the new buildings to have a maintenance
and access
certification submission. What it means is the building being designed nowadays is not only good in terms of current requirement, but in the future, for maintenance or replacement or future retrofit, it will be staged for that kind of property. Whereas the old building, you have to do the bamboo scaffolding, etc.
Yeah. Good point. Okay, so we have all of the risks and the possible challenges that probable challenges that we're facing in facades and insurance. Grace, how is the world kind of moving from your perspective in the certification space and the code development space to address some of these challenges? And my second question will be, what kind of adoption are you seeing of those?
Okay, so maybe I could share it from the green building perspective. What I'm seeing is that maybe 5-6 years ago, in the green building, like certification, design, standard, we start to look at how we understand and assess those climate-related risks. But then now, if you look at green building standards around the world, like the one in US, in UK, in Hong Kong, now they have all evolved to incorporate more requirement related to climate resilient design to reward not just risk assessment, but also adaptive design, as well as starting to look at resilience evaluation to see, those resilient planning strategies, whether they are adequate, whether they're good enough. So different organizations, in fact, they are now looking in to develop standard related to assessing not just climate risk, but natural disasters, and the risk, the recovery after those disasters events, and also the resilience strategies and adaptive design. So maybe one example is the ASTM standard on property resilience assessment, which has just been published last year. And now, because I'm on the USGBC Resilience Working Group, we are also looking into how to adopt some of those ASTM, the property resilience assessment approach into the green building standard. The PSA, the property resilience assessment approach in the ASTM standard actually includes 3 steps, and it covers not just climate risk, but also natural disaster like earthquake, and also other safety concerns like fire risk, but of course flooding and some of those extreme weather events and extreme heat is top on the list. And there's a 3-step approach. The first one is hazard identification. The second one is to assess the vulnerability, but at the property level, asset level. And also the third one is to identify resilience strategies. So because there's a property level risk assessment and resilience assessment, so we look at like structural integrity, material durability, and also any flood prevention and fire risk protection design, etc. So if you're interested, you could, look into that. It's a voluntary guideline, but I'm seeing, more organization, they are trying to adopt it. And for like green building standard, maybe I could also give you a few examples, like in BREEAM in UK, they reward adapting to climate design to recognize measures to mitigate the impact of extreme weather conditions over the lifespan of the building. So it's not just looking at a snapshot. It's the same for the ASTM standard. They recommend annual review of the property resilience assessment, or after any major hazard event happened. And then indeed, the US standard, it include climate resilience assessment and award comprehensive assessment of natural hazard for climate resilience. And it aims to enhance the awareness of these hazards and also increase transparency of those risks. So it emphasizes how we communicate those risks to the community, to the stakeholders, so that they could get more prepared and enhance the resilience of the whole community. And also, it reward enhanced resilience site designs as well as resilient space. So to support those design features that could increase the capacity of the occupant to adapt to changing climate. And for this, there's a pathway which award design for occupant thermal safety during power outage. So we would consider both extreme heat and extreme cold. So I think that is very much related to the facade design as well, and the operation and maintenance, of course. And in Hong Kong, our Beam Plus, it also award design for climate change adaptation. So I think all this green building standard, we are evolving. We are also learning, from previous climate event and how we could adapt our standard. And also in the hope that, green building standard is still voluntary in a lot of region, but then if it become, mainstreaming the climate adaptation and resilience. So later on, it may become resilient design code in the region. Thank you.
Yes.
Can I pick up on, sorry, me again, just to pick up on something that, so Grace mentioned resilience a lot. So I focused on mitigation, trying to stop something from happening. Yeah. But resilience is hugely important, and even from an insurance perspective. So if you take out property insurance, we often call it PDBI, which is property damage business interruption. So the resilience element to, if and when something does happen, to be able to get up and running quickly is hugely important to that business interruption side. So again, resilience can impact positively on the insurance, and it's something I know that Woody's worked a lot on as well with Link.
Yeah. I mean, I was just thinking, so when Grace was talking then about all of the different certifications and how that is moving in the right direction, whether, what kind of buy-in is happening from your perspective, Grace, from kind of the insurance industry, from developers that are facing these risks or kind of whether they have already and lost asset value, and then also the facade industry, because our risk is increasing along with everyone else's.
Maybe just a quick response to you. All those resilience-related credit in the green rating, there's a study that the uptick is not high yet. It's around 20-25% of the embedded project would accept those resilient credit. I think the reason behind, maybe there's a cost concern, or maybe they worry that some of the design may not be fully aligned with the building codes in the region. So this is also something we really need to, work into and to make the alignment. Thank you.
Yeah.
Yeah, I think in Hong Kong, we thought BD is in the right direction. The requirement for the maintenance and
BD is the buildings department. And
buildings. Sorry, I have to talk in English.
I'll translate.
I was a real estate broker before.
Oh, good. There you go.
So this building is maintenance, building maintenance and requirement from BD is, I think, will be helpful in the facade industry, because you mentioned about the quick turnaround during catastrophe or extreme climate event, and I think 10 years ago, before this implementation, if you shattered a glass, we have one project. I have one project long time ago that the glass is sourced from US. So the lead time for the glass is about 4 to 6 weeks at the best. And you will not put a scaffolding until you receive the material. So the turnaround is almost 3 months because it's in the middle of the high-rise story, and for 3 months the end user, that office cannot be used, that corner office cannot be used. And having this building maintenance requirement helps because you can put a temporary material in there without putting a bamboo scaffolding or whatnot, just by using the MNR and
or the plywood that we saw after Typhoon Mangos.
So now on our design, because of this requirement, our design is also evolved. Now we have to think, we're trying to control the size, the weight, how the material will be replaced. Unlike before that, as long as it's been built there, structurally glazed. Henderson is one good example. No site structural sealant, no application of structural sealant. With this building requirement of having a maintenance regimen, this will help the property to turn around quickly and make the insurance a bit more.
Yeah, and also I'd say reduce that degradation issue that we're seeing accelerate.
Yeah.
I mean,
also,
you were talking about that new building, right, with the mold.
Yeah. For the old building, you can see a lot degradation of aluminum panels. And I understand on the property management point of view, the building is designed that way, and there's no provision for quick replacement. And I know it will be costly to retrofit it. There's some contractor here. I met some of them. They build this kind of module for retrofitting, and they made a presentation to us, and it's good. It's good. You can update the value of your property just by doing retrofit. Now, I think the reason why it doesn't, shut up, I mean, it doesn't be accepted is because there's no study what is the return if we do the investment. So I think
we have a study of return.
Yeah, so maybe it's good to mention it. What is the return? Let's say we retrofit a 40-story building with the local requirement to make it ready for the next 25 years or so.
Yeah.
What will be the return of that investment in terms of number of years and how much value it will add to the
continuation of that value. We have 1 minute left, and then I'm going to see if we can open to questions. I've got a question before we do that. Hong Kong has really extensive number of old building stock, and it also has new buildings. So the new buildings have been built to current codes, which don't wrap in climate resilience criteria. The old buildings are usually poorly maintained, as a general statement. Some of them may even be self-insured, which is a different type of problem. How do we drive uptake of adaptation across the industry for safety, for operations, make sure that we're not impacting other people kind of around the community? What are your thoughts, Ed, first?
I think you got to demonstrate the economic value of it. We all want to do good for the world, but things only really happen when you demonstrate the economic value. If you look at the green transition, every building that goes up now has to be LEED premium or some kind of high grade. That started to come into effect when people really saw the economic value of it. Then WELL certification came along, same thing. Not many people were taking up, and then it exploded because people saw tenants want to come to a building with the same.
That's comfortable.
Yeah.
Yep.
So wired score, another certification. So when you can demonstrate the economic value of it, then people will get on board. And to demonstrate that value, again, goes back to the point of we need to look at probable loss and how that is expected to change over time.
Yeah, which means that the building owners need to do some of the work.
Or we do it for them.
Woody, do you have
Yeah, and I totally agree with Ed's point. And it's especially relevant for Link. The average age of our assets in our portfolio in Hong Kong is 35 years. We have, I think, 8 properties in Hong Kong built in 1970s. So it's something that we have to look at. And as Ed said, it's the economic upside for us is in protecting that asset's value. And making sure that there are not incidents where, for example, there might be spalling or there might be leakages, climate risks, or even disruptions to our tenants, our shoppers, which will impact that valuation. And protecting that value, that economic value, I think would be the biggest incentive for us.
from a non-financial perspective, Grace?
Yeah, sure. I think we need to align policy, the industry, or the market, and finance. And for the policy one, there's a lot, the government could do, many tools they have. In addition to setting carbon neutrality target, maybe we could set out resilience target, for our cities. And also some support, like fast tracking the approval for resilient design or retrofit, or maybe even some tax rebates that's been done in other countries for resilient retrofit. And also, for the industry, the market side, in fact, the better insurance premium definitely is very good, and also the better property valuation, as well as some of those ESG ranking or benchmarking. That's also include climate resilience as one of the key consideration. And for finance, we focus on climate mitigation in our green finance before, like energy efficiency, green building, and waste management. But then now, I think we should also,
move in that
to climate adaptation, resilience, in the green finance angle, and how we could facilitate that. The industry could also help with, enhancing our standard and some performance benchmarking, so that they can draw the line, with how it is eligible as a climate adaptation resilience financing. Yeah, thank you.
Thanks, Grace. And Marius?
Well, on technical people like us, Liz, I think for us, I'm speaking on the behalf of industry as a consultant, as facade consultant or engineer, we have to safeguard our role. We have to safeguard the property of our client. We have to make sure that aside from the existing regulation and requirement, we have to think ahead. The climate will change forever. It will not stop. There will be another, maybe in a decade or so, there will be another, the typhoon, maybe right now we're up to typhoon 10, who knows, maybe it exceed 235 miles per hour or so. So we have to think of ways. We have all the tools, technology, and a lot of new materials are emerging. I think on our part, we have to start to explore these materials, and make a scenario. In our company, we have sustainability, we have everything. I think we can use that to move forward and safeguard the interests of our client, and make sure we can have the valuation with these two gentlemen and their colleagues in the future.
Excellent. Okay,
So time is up. Are we allowed to do questions, Afreen? Just one. Hands in the air, the quickest one wins. Nope. One at the back.
Woody mentioned the flash flood that we had a couple of years back. Now, presumably that would have been, let's just say, a 1 in 100 years force majeure event. Now, you took some retrospective actions there, but what happens if in 2 years' time we have a similar event? Would that still be considered a force majeure? Because then it's not a 1 in 100 years event anymore.
Sorry, would it still be considered
a force majeure? If there was another similar storm, because again the frequency is then is the new norm.
No, so that is the approach that we're taking as well. We believe that these extreme events are part of our operations now. The scenarios that we're taking in terms of future climate risk emissions, we're taking the worst case scenario now. We don't think that this is going to be an infrequent, rare event, 1 in 500 years anymore. That's why we're applying these measures, not just to Temple Mall, but across our portfolio. So yeah, definitely not a 1 in 500 year approach anymore. It is an operational regularity for us, these kind of events.
So to put that in more technical terms, the IPCC has a bunch of different scenarios. You're using 8.5.
Using 8.5.
8.5 degrees warming.
No, so SSP 8.5.
Oh, SBS, sorry.
SSP 8.5.
Okay.
So the extreme case, worst case scenario is the one that we're using in terms of assessing which properties are most at risk in terms of flooding and typhoons. And based on that and the recommendations from the risk engineers from AXA, we have put in place the measures that I have just described.
Excellent.
Yeah.
No other questions. No time. Thanks, everyone. Please put your hands together for our panels. Thanks for coming.
Thank you for the panelists for this engaging discussion. I think it's really... Thank you for everyone to attend, and thank you all the speakers, the organization, the supporting team. I would like to see you on the future events. Thank you.